Okay, I saw the stream has started, so once Alda gives me post back, I'll go ahead and get it started.
All set,
Okay,
Eric. You're good to go.
yep, awesome, thank you. I'm gonna hit the record right now. Please turn your camera off if you are on camera right now. Got a couple more still on camera. Okay, I'm going to go ahead and get started and I'll spotlight videos so we can get this going. Okay, so we are recording. I am going to hit start, and as soon as I hit start, everybody will come in. I'll give it over to you, Elvira.
Thank you. Good morning. Buenos días a todos y a todas. Bienvenidos. Welcome. On behalf of the University of Illinois System, Illinois Mexican and Mexican American Student Initiative, I-MMAS, I thank you for your participation in the 15th International Symposium organized by the University of Illinois System, I-MMAS. I am Elvira de Mejia, a professor and the executive director of I-MMAS at the University of Illinois System. I-MMAS organized this symposium on water and the environment in partnership with the National Autonomous University of Mexico, UNAM, the Faculty of Higher Studies, Iztacala, the University of Illinois, Chicago, the University of Illinois, Urbana-Champaign, and the University of Illinois, Springfield. Thank you all for your generous collaboration. I thank all authorities and representatives of different institutions for their presence and support, especially Dr. Timothy L. Kalin, President of the University of Illinois System, and Doctora María del Coro Arizmendi Arriaga, Directora, Faculty of Higher Studies, FES Iztacala, UNAM. The objective of this symposium is to promote a multidisciplinary discussion to develop strategic collaborations among scientists from the FES Iztacala UNAM and the University of Illinois System in the areas of water and environment. We will learn today about innovative approaches for water resource management and environment quality enhancement, explore opportunities for cross-institutional research collaborations, and live with actionable strategies we can apply in the real world. On behalf of I-MMAS, I thank all the speakers for the meaningful and engaging presentations. Thank you for the exchange of knowledge and experience on the highly relevant topic of water and environment. Thank you to the attendees for their interest. We have a large number of people registered in this topic that affects us all. A special thanks to Dr. Isaac Obed Perez Martinez, Department of Internationalization, FESI Secretariat of Development and Institutional Relations, who promoted the development of this symposium. I thank the moderator, Dr. David Andrade from FES Iztacala UNAM, who will keep us on track. I thank the people behind the scenes, Mr. Eric Olson, Educational Application Support Specialist at the University of Illinois System, Ms. Nancy Salinas, and Mr. Aldo Mora, UNAM, Chicago. Now, I'm pleased to introduce Dr. Timothy L. Kalin, the 20th President of the University of Illinois System. Since taking office, President Kalin has led a surge of growth across the state's flagship university system. Enrollment is at record highs, including increases among in-state and underrepresented students. President Kalin, a leading researcher in geophysics and space sciences, champions efforts to expand research discovery that drives progress and job creation. That includes helping lead the creation of the Discovery Partners Institute, a world-class research technology talent development and business building center in downtown Chicago, and the Illinois Innovation Network, a system of satellite hubs that combine research, public-private partnership, entrepreneurship, and workforce training to spur inclusive economic development across the state. President Kalin was elected to the National Academy of Engineering in 2007 and is a member of the American Geophysical Union and its past president. A native of Wales and a U.S. citizen, President Kalin received his bachelor's degree in physics and astronomy at the University College London, where he also earned his doctoral degree in atomic and molecular physics. It is an honor to have President Timothy Kalin deliver the welcome remarks. I'm delighted to pass the virtual microphone to you, President Kalin.
Thank you very much, Dr. De Mejia, and welcome to all. Bienvenidos. Yes, I'm Tim Kalin, President of the University of Illinois System. I'm delighted to join you here today. Me complace enormemente que nuestra colaboración se esté tomando este tema tan en serio. Una gran parte de la humanidad ya está expuesta a problemas relacionados con el agua, y una comprensión profunda y una gestión eficaz son de vital importancia para nuestro futuro común. So there's no more important research being conducted anywhere right now. Work focused on the environment and water. The need for sustainable solutions to the challenges we face in securing clean water, clean air, healthy soils, and thriving ecosystems has never been more important. This is also an area that illustrates that these needs are shared across both of our countries and across the border between us. The I-MMAS initiative was founded to meet these shared challenges, to work together in a generous, collaborative spirit, together. And today's symposium, the 15th, in particular stands as an example of how we can connect our brilliant and innovative scientists to seek solutions for us all. The work we will all soon hear about is a product of what is now a years-long partnership between UNAM and University of Illinois System. I am forever grateful to UNAM Rector Leonardo Lomeli Vanegas for sharing this vision of how these two world-class institutions can deeply partner for the good of people all over our two countries. I'm also delighted to welcome Rector Maria del Corro Arizmendi Arriaga von UNAM's Iztacala Faculty of Higher Studies. In addition to her work as a leader in higher education, Rector Arizmendi is also an accomplished ornithologist. Mexico City in particular has benefited tremendously from her innovative work to conserve hummingbird populations. And I personally congratulate you and thank you for that kind of work. This symposium brings together so many researchers, including a number from our three U of I system universities in Chicago, Urbana-Champaign, and Springfield. And the agenda for today will give you the opportunity to consider, among other areas of research, the role of recycling in meeting supply challenges, wastewater issues in a major city, in this case, La Ciudad de Mexico, how AI might help in site remediation, risks posed to suburban water supplies in Greater Chicago, and the restoration of aquatic systems in Mexico. I want to thank all of our speakers for being part of this gathering and everybody else here today for taking advantage of what I believe is a tremendous opportunity provided through I-MMAS. This initiative is a real success story and needed, so needed in the world today for researchers and their students who grow through the opportunities provided here to collaborate and work together across disciplinary and institutional boundaries. And this happens across such a wide range of disciplines. And of course, the people our universities and UNAM are dedicated to serving are the ultimate beneficiaries of this important work. We hope, of course, that even more exciting new collaborations and opportunities grow out of the presentations you are about to hear. Thank you all again, and I hope the day is productive, stimulating, and rewarding for you all. Muchísimas gracias.
Muchas gracias, President Kalin. Thank you very much, President Kalin, for your kind delivery of the welcome remarks and for your constant support to I-MMAS work. Thank you. Now we have welcome remarks from Doctora María del Coro Arismendi Arriaga, Directora, Faculty of Higher Studies, Iztacala, UNAM. Doctora, es un honor tenerla aquí. Muchas gracias.
Buenos días a todos y a todas. It is a pleasure to be here with you. I am the director of FES Iztacala, and I am very pleased to share with you the opportunity to collaborate between the Mexico City scientists that are working with the water systems in here for a long time, and you, because I think internationalization is a very important task at the university, at the UNAM development in this time. So I am very pleased to be here. I am pleased to share with you this opportunity, and I congratulate all the work in here to have us here now. Thank you very much. I feel welcome to FES Iztacala and UNAM. Por mi raza hablar el espíritu. Thank you.
Oh, sorry. Thank you. Muchas gracias, doctora
Gracias.
Arismendi Arriaga. Thank you so much for your welcome remarks. Now it's my honor to introduce the first keynote speaker, Dr. Rachel Haverlock, Professor and Director of the Freshwater Laboratory at the University of Illinois, Chicago. The topic is Meeting Water Supply Challenges Through Water Recycling. Thank you, Dr. Haverlock. Please show your slides.
Good morning, everyone. I hope that you can hear me, and also I'm in the process of sharing the slides. Wonderful. And please don't hesitate, team, to let me know if anything looks amiss on your side. Good morning. Thank you so much for including me in this wonderful gathering that I personally hope is the beginning of many more collaborations to come. I'll be speaking about meeting water supply challenges through water recycling and reuse, but I'd like to begin by addressing the social context of meeting these supply challenges. My initial training was in environmental peace building, specifically the power of transboundary water collaboration. I know that many forecasters like to speak about coming water wars, and I want to emphasize with this graphic how, in fact, water agreements, water sharing agreements within countries as well as among countries are among the most durable form of treaties and diplomacy. And the reason for this, I think, might be clear to all of us, but can't be overstated, that every community, industry, individual, and species that draws from a common source of water has a vested interest in its long-term quality and quantity. My own work, the first transboundary basin where I was active is the Jordan River Basin in the Middle East. And I just share this slide to make a point that these water agreements that are so vital and so durable in our times are also socially emplaced, which is to say, as much as technology and science and social collaboration is vital, culture has a role to play in this, because water is not only an element and certainly not a neutral element, but it's something that is valued by communities in specific ways. And what I found in my work in the Jordan is that elevating these cultural connections, finding those common points, and finding ways to integrate them into scientific projects can have a very positive effect. Here was an event we hosted at the University of Illinois in 2015, and this was a memorandum of understanding among mayors from different countries around the Great Lakes Basin as well as around the Jordan River Basin. Of course, there are binational levels of water sharing. The International Boundary and Water Commission between the United States and Mexico has a very effective relationship since 1889. In my transboundary work, I've had a chance to meet with some of those commissioners over time. And up here in Illinois, we are also part of the US-Canada International Joint Commission, which has adjudicated boundary issues and water sharing since 1909. But here at our Illinois-Mexico meeting, I want to emphasize that transboundary water relationships can also develop between non-connected waterways. So there's many ways to kind of have these sister water relationships. I'll just speak briefly. My freshwater lab at the University of Illinois, Chicago. You can see my team here under the Chicago canals. We've been working to both address water quality and discharge issues in our canals around Chicago while leveraging culture as a way to engage the community. And here in Chicago, majority of the community members around these canals are Mexican American, and we've been very interested in efforts around the Xochimilco canals, especially in the way that cultural events and boating on Xochimilco is a way to engage larger numbers of people in remediation issues. Okay, so moving ahead to the water scarcity issue, this is something that we dealt with, in fact, successfully around the Jordan River, is that collectively addressing water scarcity issues along a number of boundaries can stabilize social relations. It can be a very effective way to operate, even in tense situations, while bolstering economic development. So, how is it possible to address these water scarcity issues? Here, I want to speak in some broad strokes. At first, is that water reuse, recycling water, closing that loop, and redefining what we call wastewater as an essential part of the water cycle is a win-win way to do so. Water reuse, a practice of reclaiming water from a variety of sources, treating it and reusing it for beneficial purposes, can provide alternate supplies, in some cases for drinking water, in many more, as my own research addresses, for industrial or agricultural non-potable uses. This is a key way to enhance water security, sustainability, and resilience. States like California and Texas are now moving quickly to incorporate recycled water into their drinking water supply. El Paso and Los Angeles, as you can see here, really have the leading sites of this drinking water reuse. And back to these transboundary relationships, there are potentially positive implications in that for transboundary water supply negotiations around both the Colorado River and the Rio Grande. My current research focuses on industrial water reuse in the state of Illinois. We can see here on this beautiful map that many of our boundaries in Illinois are, in fact, water boundaries, whether Lake Michigan or the Mississippi. So it might seem as if, right, Illinois is not a right place for water reuse, but like most places on Earth, we are facing pretty precipitous groundwater drawdown. And I'd like to suggest today that this closing the loop and redefining wastewater as a vital element is a key way to address that. As well as addressing these water supply issues, incorporating wastewater into the water supply can also open a stream of revenue. So where utilities currently pay to treat waste, bringing recycled water into the supply can also net water rates that can be reinvested in some of the state-of-the-art treatment and the necessary conveyance infrastructure. I'm just quickly going to address some key sites for potential water reuse, such as the expansion of data centers, because data centers, particularly the kind in development now, have substantial water needs for cooling, but they do not need drinking water. The cooling systems can rely directly on water supply to cool the surfers, but sometimes this water supply is kind of on the back end by the water used when data centers incorporate electric cooling, right? The water might not be on site, but it is in the back end. Some sites operating or under construction can repeatedly reach a water use of about 5 million gallons of water per day. Here, I think in the interest of time, here's a list of some of these various cooling methods. And as we'll hear from the next speaker, right, this is where that energy water nexus has to be calculated. Again, why is this so appropriate in Illinois? Here are our Great Lakes states and the number of operational and planned data centers. And you can see that regionally, Illinois is leading the pack. This strain that we are seeing in many parts of the world on local utilities and water supplies, it can be eased either through on-site closed-loop systems or by sourcing municipal wastewater for data centers. So there's a kind of an overview of what my team and I see as the kind of like low-hanging fruit of fusing the innovations in water recycling with this expanding industry. We've also looked at meeting the industrial needs of communities joining our Lake Michigan supply through dual pipelines. Here is a vital map from colleagues at the Illinois State Water Survey, looking at where some of that groundwater drawdown has reached emergency levels that bring communities to search for alternate supplies. Most of these communities plan on joining the Lake Michigan supply system, which is a phenomenal water source in our Great Lakes, but it is neither limitless nor is it allowed for unregulated drawdown. There are limits placed on how much water can be taken. So my team and I proposed in meeting these supply challenges for communities that need to shift off their groundwater supply, that when there are available freshwater sources to meet those needs, they should be met. But at the same time that new infrastructure is constructed, it should incorporate water reuse through what we call a dual pipeline system. That is, right, a blue pipe to meet those drinking water needs and a purple pipe for these new communities joining on to both meet their industrial needs and to make provisions for expansion. At the same time, meeting new water needs, whether from data centers or new communities with recycled water, it, from my point of view, offers the kind of ideal place to integrate this new supply, right? We know that it is always easier to incorporate innovative infrastructure with a new build than it is to retrofit. But at the same time, new industries and new endeavors don't happen in a vacuum. They're often zoned in industrial hubs. And so at the same time that we're thinking of meeting needs, new needs through recycled water, we also see that this is an ideal time to look at water use, water projections in our existing industries. And in fact, to develop, industrial hubs running on recycled water, either around wastewater treatment plants or, in building a pipeline of water to these industries, make sure that there are multiple sites that can hook on and attach. So part of what this offers, water recycling in our part of the world, is that the fresh water in the Great Lakes systems can be preserved for human uses as well as ecosystem stability, while recycled water can be looped through many times, dedicated to industry and agriculture, and in expanding supply in places where there is available water. This can also help with the absorption of production and agriculture from regions that no longer have that kind of sustaining water supply. Thank you so much.
Thank you very much. Thank you, Dr. Haverlock. You have a question, and please, we invite the participants to write their questions in the Q&A tool. So, Dr. Haverlock, could you speak more about examples of social relations stabilization and any best practices on framework that supports this?
Yes, thanks so much. So yes, really these visions for water reuse comes out of that work in the Jordan Valley. And without belaboring the point, there are very tense relationships around that particular border, which also have negative effects on the river itself. The Jordan River now runs with about 4% of its historic flow of water. And that is climate change certainly plays a role, but it's also because the riparian countries are diverting water outside a framework of water sharing. So there is no boundary commission like we have between the US and Mexico or the US and Canada. However, at a more grassroots level, through environmental peace building efforts, we were able to convene mayors in the Jordan Valley. And on the one hand, ask them the kind of water and environmental issues that they were addressing, but also to bring in scientists and experts who conducted studies about the long-range water quality and water quantity. And if people are interested, we can speak more about that process of how scientists can operate effectively within politically tense environments, because that's certainly part of the story. But I want to answer the question more directly. So we found a region of the Jordan Valley where there was literally no wastewater treatment. And that had very negative effects on public health and also groundwater health. And so in convening the mayors and conducting that study, ultimately the mayors conducted their own capital campaign and introduced wastewater treatments with, it was a small pilot component that involved some water recycling, which was able to alleviate some of the scarcity that was debilitating local farmers. So again, this was in a very tense situation. By working at that mayor-to-mayor level, we were able to both finance and install infrastructure, water reuse and treatment infrastructure that had widespread and cross-community benefits.
Thank you very much for your answer. There is another question. Are you part of the solution in remediation in Xochimilco, We saw pictures of the canales in Xochimilco. Do you have any comments?
Yes, that was aspirational because I'm hoping that this meeting brings us together with researchers. So members of my team are very active on remediating a famous part of the Chicago Canal called Bubbly Creek. It's in a neighborhood of Chicago Pilsen, which is a strong historic Mexican and Latinx neighborhood. And so these canals, they have a lot of corollaries with Xochimilco. So this is something that we've been very eager. We are, really hoping that this meeting might kick off a kind of partnership between the canals of Chicago, the Xochimilco canals, how we can integrate culture with water remediation. There is a remediation program going on now in Bubbly Creek that involves some really cool floating wetlands. So yes, here there's been some outreach by our partners working on Bubbly Creek in Chicago, but yes, but this is not something that's been accomplished, but something that I hope might kick off here. And just a quick nod to the University of Illinois system, which has provided us grant funding in the past to support that work on the Chicago canals. So we've been convening, we've attracted other grants and community engagements, and hoping this might start a next chapter in that collaboration with Mexican partners.
Thank you. There is another question. How many data centers of your knowledge are already using treated wastewater as cooling media?
Yeah, so it's hard to place a number on that, but I'll speak to the issue. When it comes to new data centers being developed in places in the West that have very well-known and well-publicized water supply challenges, California, Nevada, Arizona, that is, it's sort of one of the two de facto methods. So data centers for generative AI opening in the American West at this point are either relying on air cooling or they are incorporating treated wastewater. There's even one case, there's a project underway now where it's a massive data center campus outside Reno, Nevada. And they're actually building a pipeline from a wastewater plant in California that's crossing the state line. Outside, and I'm speaking in the US context right now, outside of the American West, data centers using treated wastewater can be more of a one-off. There's a Microsoft center under construction to the north of Chicago in the state of Wisconsin. And we're hearing plans for a closed loop system. But again, I would say without quite being able to put a number on it, my general sense of what's going on is when you have development of data centers in places where the public is well aware and well informed about water scarcity issues, there's motivation to develop these things. In places where the water supply issues are not as well known or not as well publicized, the de facto plan is for the data centers to connect to the drinking water and enter into agreements with the utilities. One approach that's underway in US states right now is actually to very quickly commission sort of water supply mapping so that particular regions within states, right, know whether this is a necessary approach in the short or long term. So my general answer is that this is underway in regions plagued by drought, whereas regions where water supply is not as well studied or well publicized, it's more exceptional.
Thank you. Thank you very much, Dr. Rachel Haverlock. You have congratulations in the Q&A and also more questions, but please answer them in the Q&A so everyone will see your answers. Thank you again, and congratulations on your wonderful research. Thank you.
Thanks so much.
Thank you. So moving with the next keynote speaker, it is now my honor to introduce our next keynote speaker, Dr. Yu Feng Lin, Director, Illinois Water Resource Center, Principal Research Hydrologist, Illinois State Geological Survey, Prairie Research Institute, Clinical Professor, Civil and Engineering, Engineering Research Professor, Natural Resources and Environmental Sciences, University of Illinois, Urbana-Champaign. Please, Dr. Lin, show your slides. You have them.
Thank you very much, and it's really a great honor to be invited by Alvera, and it's really a great pleasure to be able to speak to all of you today. And of course, it's always nice to follow after Rachel's talk, because she always gives us such great talk, and then it has been a pleasure to be her collaborator for a while, and we have been tackling on some similar water issues together. And hopefully today will be an opportunity to know more of the colleague here, and especially from Mexico, and then we can work together. And so I do have some experience collaborate with some colleagues from Mexico, and especially I was trained as a groundwater modeler. So the groundwater issue at Mexico City is pretty well known. And as the executive editor of the Journal of Groundwater, and I've seen a lot of study, a lot of case about groundwater at Mexico City. And then on my cover slide shows there was one event I was giving a lecture to the military leaders from 8 countries in Central and South America, and was hosted by U.S. Army Corps of Engineers. In that lecture, we were talking about the groundwater and the geothermal energy connections. And so hopefully that lecture could bring some military installations be more sustainable or resilience improvement on that. So that was a really good experience to work with colleagues, and not only the academia, but also from military researchers on the water energy nexus. So today, I would like to focus on some of our work on the water energy nexus for the AI infrastructure. So our team has been working on the water energy AI nexus in many issues and many opportunities, including using AI as a tool to help water energy nexus study. But today I want to focus on the other direction, is how water energy nexus could help the AI infrastructure development, which including data centers, and where the Professor Haverlock already gave a lot of good insights on that. So I would like to start showing some key numbers on the water energy nexus for the AI factories. So AI factories, what is a term, actually, if you are following all of the AI development, and including the Jason Huang, the CEO of NVIDIA, they already sees the AI development is not one single type of the facility, not just data center, not just semiconductor manufacturer. It's a whole upstream, downstreams process, supply chain together. So this is just some numbers. I'm not going to go through all of those in detail for the time's sake, but just kind of let you have a quick scan on what kind of the magnitude we are talking about here. So there are some key numbers I want to kind of address here. So the second one, TSMC, the Taiwan Semiconductor Manufacturer Company, and right now they have one fab at Phoenix, and one fab, which means one facility, and with their future investment, they are projecting 6 fabs. right now they have one fab is functional, is operating at Phoenix, and that fab is using about 4 million gallon per day. And then with 3 million gallon can be recycled and reused. And then that means 1 million gallon per day gone every day on that. So that's the chip manufacture part of it. And for the data centers, there are all different kind of data center, from crypto coin mining, or for the right now, for our kind of GPUs, the hyperscale data centers use a lot of energy and water either way, and for their cooling system on that. And Illinois actually is one of the hotspots in Midwest and the Great Lake region. So we have the highest number of the data center in the Great Lake region right now, and Ohio is catching up. So in the recent study, it also shows the water usage for the data center actually is less than 2% of the US water usage for now on the direct usage. However, for data center, more than 75% of their water usage is indirect. And what do I mean indirect? So that probably need to go back to some fundamental design of the data center. If I use data center as an example for the AI factories. So for the data center design, they have many factors, but we can kind of still down to 3 major factors: PUE, WE, and CUE. So basic is what's the efficiency of their power usage, and what's the efficiency of their water usage, and then what is the carbon footprint on that facility. So it all depends on the local market. And of course, for business, I mean, the ultimate goal is the cost and profit, right? So most of data centers are designed for the based on the local market. So which means data centers, they are not the same. They customize, they optimize based on their local market. So if a data center says, oh, I don't use much water, it could be they use a lot of electricity for their cooling. Vice versa, if the data center not use much power, as they say the efficiency is very high, and then that probably means they use a lot of water. And then if the data center say, oh, we don't use much water and electricity, that could be they use electricity, which has a lot of carbon footprint, which means pretty dirty energy. So there's no free lunch. So think about this as like a triangle play. You need to kind of balance on it. So why does that matter? Because when you get information about, oh, our data center don't use energy very much. Oh, our data center doesn't use water very much. You got to understand that principle underneath it, and is that a whole story or not? And so that's some kind of basic fundamental information I want to deliver here today. And when I talk about fundamentals, I'm not just talking about how we do the assessment, but also what is the physics behind the scene here. So our team has been working on these issues probably since early 2020. And then, of course, everybody knows in 2022, when GDP3 pump up, everybody kind of, whoa, this is something new. So here I'm not going to cite a paper. I'm just going to show you the presentation actually from NVIDIA in 2023 and show you some basic fundamentals physics on how we are going to see this problem from the past, present, and the future. So in this presentation presented by NVIDIA, and I want to highlight this graph on your bottom right. This shows you the chips. We are talking about cooling, and we are talking about for the performance of the chip. The blue line shows the CPU, central processing unit. And so you have heard about Intel chips, AMD chip for your home PC, for your desktop, and those are the CPU. And basically, over years, from the 1960s, they've been following Moore's law, and which is about increasing 50% every year. And then somehow in the recent 2 decades, that curve has been slowing down. And one of the main reasons is because of the heat. And based on the presentation I've heard in early 2000, Intel engineer already know that's a big problem, which is the heat issue. And the Pentium, if any of you remember the Pentium chips, that Pentium CPU already emit almost the same heat or even more heat for the same area come out from the space shuttle nozzle, the rocket engine of it. That's how hard that thing could be. And now we are talking about acceleration computing, machine learning, and using GPU. That is not in the same scale. And so based on this graph, you can see the computation intensity and the heat going to emit is not in the same scale as Moore's law of it. And that was before, and that's still now, and that will be the future. We need to pay attention on why we are tackling this issue right now. So what have we been doing? So I, as in the introduction about me, and I wear several hats. So I do research. I also help our providing information for our policy and decision-making support, and then at both Great Lake region and also the national scale. So in the state, our team has been really working on the water energy nexus and focus on the groundwater and the geothermal energy solution of it. But my center, our center, Water Resource Research, Water Resource Center, has been founded by Congress since 1964, and we are also funding a lot of research on this topic. And then also we have been sitting on several water energy nexus for data center development project and to provide them viable information. And hopefully this could be a win-win situation from the environmental point of view or from the economical point of view of it. Because bottom line is we are not going to stop the AI development. However, how can we make it more sustainable and more long-term growth in a steady path of it? So also in the Great Lake regions, as a Great Lake commissioner, I've been working with scholars like Professor Havlock and how we can provide a good solution and policy support. And like the Great Lake Commission have a recent 2 resolution has been adopted on that. And one of them is for the water reuse, as the Professor Havlock mentioned earlier. And at national levels, as this year, I'm the president of National Institute of Water Resources. And so I've been forming a new national committee to address this issue by have a collective mind from all different states. And some of those states are really into this topic. They volunteer to be a member of the committee. And we are really working very hard, try to be the neutral hub among industry and decision maker, policy maker, and local stakeholder on that. And so we also working with the industrial partner like Epic System, which is the largest healthcare software company and in the United States and in the world. And their headquarters actually is in Verona, Wisconsin, right next to Madison. And they have been using a very viable solution for water energy for their data centers and cloud service, which I will show later. So this is some example I want to show you on when we talk about policy and the decision makings. But as a scientist, my team has been trying to find what is the viable solution we can provide, although there's a lot of people working on it already. So one of the work we've been working on is to tackle how groundwater system can help on the cooling and heating, especially on the energy storage and energy exchange of it. So I want to give you some example here. One is a geothermal exchange system. And earlier, as I said, EPIC in Wisconsin, the whole campus right now currently is using more than 7,000 geothermal exchange loop on their campus. The benefit is you use earth as exchange and store the heat. And then the heat it could be harvested for the later use when there is a need for the thermal energy of it. So this is not to use hot geothermal to produce electricity. This is using earth as exchange media, just like air or water. And instead of data center, they exchange the heat released to atmosphere, then that we store it in the subsurface or exchange with subsurface. And the other example is we have been working with federal agencies like Department of Energy and Department of Defense, and then to help them to use geothermal exchange as their solution for the waste heat and also cooling system of it. And one example is the cyber infrastructure for the Department of Defense, the largest cyber base. Actually, they are using a geothermal system of it. And so this is going to be one of the vital solutions in our point of view, because actually if do some kind of Google and then some search, you can find the EPIC system is not the only one. The Microsoft, Amazon, and Google, actually they've been using this kind of system for a while, and also in Europe. And another one is a new project. We just got the possible, a very positive response from Department of Energy is called reservoir thermal energy storage. And we have been using our campus as a test bed, living laboratory for many geothermal project already. And this is a new one. We just got the update from Department of Energy. We are going to use our campus as a test bed for a new system called Reservoir Thermal Energy Storage System, and which is to use a different heat at different level from power plant, from chill plant, from data center, our national petascale computing facility, and then use our research park, and then to store the heat or the cold from different facility, and then use it for the other facility when they have different temperature need of it. So benefit of it is when we talk about power solution and energy solution, a lot of time we talk about how many gigawatts, how many megawatts we need. However, on the other side of the coin is how stable your energy can provide on it. And actually, let's talk about battery or the energy storage. However, energy storage is not always electricity, right? So actually, thermal energy can be stored as a battery and then to use for the thermal energy. Subsurface, especially aquifer, could be a really viable solution of it. And that's what we have been working on. So this is an example we have been using our campus as example because subsurface is pretty complicated. We know the characteristic of subsurface. We can really use a lot of good work of it. So on this chart shows in the 10 feet, on our campus, we can have 4 different materials, and the thermal conductivity can be 6 to 8 times difference of it on those 10 feet materials. Then when they are wet, it's 1 order higher. So just think about it. I mean, this is not rocket science. We just need to understand what is going on beneath our feet and to take advantage of it. So by doing that, recently, our team also working with U.S. Geological Survey to develop a new package for a very well-known groundwater modeling tool, MultiFlow. And then now the MultiFlow has the capacity to do a groundwater energy transport of it. So I'm not going to go to the detail about the programming part, but this is captured from the USGS official document on how this package can help at a different way to do the thermal transport. And the application is not only for geothermal, I mean, we can go into subsurface and surface exchange, like surface water, groundwater interaction, and then how the atmosphere heat transfer into surface water and the groundwater of it. So just kind of let everybody know this is new capacity, and hopefully the scholar, the collaborator, and the student here can take advantage of it. So if you want to trace back a little bit more study, and a few years ago, I worked on spatial issue with 3 colleagues from Europe, from British Geological Survey, from Switzerland, and from Spanish Geological Survey. There's a whole issues, spatial issues on the thermal transport for the groundwater. So this is just for your information, for anybody is interested to dig into this information on that. And I'm happy to share more if anybody would like to have more detailed information about it. So this is my conclusion slide. I mean, think about long ago in 2022. That sounds not that long ago, but from the AI development, that it has been a while ago. At that time, ChatGPT 3, we're not talking about ChatGPT 5 right now. That already using about 1 gigawatt hour per day. And what is 1 gigawatt hour? When we just type ChatGPT for fun, that's equivalent to about 33,000 US households electricity consumption on it. So in the year 2022, when Microsoft want to increase their AI capacity, at the same time, from their own report, they're increasing water usage for 34% in that year. Google actually also in their report, in that year, they increased 25% of their water usage of it. So this thing is going so fast. And then fortunately, there's a lot of good work and a lot of people care about this. And this is just 2 examples to show you, you can get some updated information, and especially for the Great Lake region. However, this is so fast again, and you can see a lot of information, but you might got information from different angle of it. How do you know which one is right or which one is unbiased? You need to go back to the fundamental as early presentations I had to show you. To understand that principle probably can help you to make a better judgment about the information you are getting. Well, thank you very much for your time, and thank you for your attention, and hopefully we can work together for the better good of our future generations. Thank you.
Thank you very much, Dr. Yufeng Lin, Director. And we don't have time for questions, but please feel free, participants, to write your questions in the Q&A tool, and Dr. Lin will be very kind to answer those over there. Thank you again.
Thank you.
Now, it is a grand honor and pleasure to have Dr. Thomas Rothfuss, Director of the University of Illinois System Field Station at Lake Springfield, University of Illinois Springfield. His topic is Enhancement of the Aquatic Ecosystem. Please, Dr. Rothfuss, welcome and show your slides.
Can you see the slide up there right now?
Yes.
All right. I want to thank the organizers for inviting me today. At UIS, I am part of the School of Integrated Sciences, Sustainability, and Public Health. I also serve as the director of the Thurkelson Field Station at Emequon and the Field Station at Lake Springfield. I was asked to talk about enhancement of aquatic ecosystems, and I'm going to do this through the lens of students examining macroinvertebrates, like you can see there on the screen at the Emequon Preserve. At the UIS field stations, we support a wide variety of research projects looking into the health of aquatic systems. We also provide educational and outreach experiences for the surrounding community, trying to connect people to their local environment and providing experiences actually doing science, not just hearing about it. I think these kinds of connections and experiences play a key role in protecting and enhancing our aquatic ecosystems in the future. I want to start, though, by talking about 2 related topics that I think quite a bit about. The first is the idea that knowledge of the world and experience of the world are 2 fundamentally different things. Both of these, of course, are important and useful. We might sometimes even use them interchangeably, but they are definitely different terms and concepts. These days, it's very easy to come across knowledge. Just ask your phone or your computer using all that AI we just heard about. It will spit out lots of information for you. Some of it might even be true. But gaining experiences, on the other hand, especially with the environment, takes more effort. This is increasingly the case as more and more people live in areas removed from nature. Christopher Robin down there, he could very easily have read an article to learn about the flooding that was impacting him and his friends in the 100-acre wood. These UIS students, they could have watched a YouTube video to learn about collecting macroinvertebrates. In both cases, neither would actually have had to come in contact with nature and the potentially unpredictable experiences that come with interacting in the real world. And I believe these unpredictable experiences are truly when we actually learn things both about the world and about ourselves and about what our knowledge really consists of. And so this brings us to the second idea that I have up there, which is generally called the extinction of experience. This concept has been around for a few decades in the conservation literature. The basic idea is that people increasingly are spending less time in the natural world and thus have less of a connection to their environment. This in turn impacts how they view environmental and conservation issues. Several studies have found people who spend less time engaging with natural spaces are less willing to support conservation and environmental causes and policies. And this, of course, makes enhancing our ecosystems, the topic I was asked to talk about today, increasingly difficult. Out of curiosity, I looked up the role of scientists in ecosystem enhancement using some of that AI. Google very helpfully provided a list of different types of practices that scientists engage in, whether it's research and monitoring, which is a pretty standard one, informing policy, predicting future scenarios, guiding restoration, all sorts of different things. You can see the full list that it spit out for me up there. All of these are good things. I commonly take part in several of them, especially with working on the drinking water reservoir here in Springfield. So these are good things. I think they're important things. But one thing really bothers me about this list. It consists primarily of different forms of gathering and transferring knowledge, and really it amounts to telling others what they should do and maybe getting to the why they should do it. There's no focus on sharing the experience of being in these ecosystems and connecting people to these places. That line there, bridging science and society, seems to at least recognize that there is this gap and a disconnect between science and the general population. Maybe I'm underplaying what it includes, but I think this is a big flaw with how we go about conservation. Telling someone that there will be ecosystem and health benefits to taking land out of agriculture and turning it into a prairie or a wetland might be a hard sell when they're thinking about jobs and income lost. Getting them out into a restored system and letting them see, smell, feel, and really experience what one of these wild systems can be may be able to turn them into supporters. And I know this sounds a little soft and maybe a little bit out there in some ways, but as I mentioned, research supports the relationship between these connections and support of policies. One of my favorite activities to do with student groups, and when I say students, this could be fifth graders, college students, or retired continuing education students, is to have them put on waders and walk into the wetland at the I-MMAS Preserve. I explain that their goal is going to be to go collect macroinvertebrates, which are mostly insect larvae where we're working, and that they will sort and look at their collections under the microscope later. They get wet, often they get a little bit muddy, and they get to handle bugs. So this is possibly the greatest experience that you could have. But let's break down this activity and how we link it together out there. First, I mentioned we do this in the I-MMAS Preserve. The I-MMAS Preserve is a restoration project that's owned and operated by the Nature Conservancy, and our field station is right there on the property. Most of you probably know about the Nature Conservancy. They're an international nonprofit working to protect environments around the world. TNC acquired this particular property in the year 2000 and began restoration somewhere around 2007 or so. The preserve consists of wetlands, prairie, and upland and bottomland forest. Historically, this area was a series of floodplain lakes, bottomlands, and wetlands connected to the Illinois River. During the 19th and early part of the 20th century, this area was an amazingly productive fishery, a key part of the freshwater mussel industry, and provided habitat for millions of aquatic birds with tremendous waterfowl hunting as they migrated through each year. As we moved into the 1920s, levees began to be constructed up and down the Illinois River separating many of these floodplains from the main body of the river in order to convert them over to farmland. Initially, these new fields were super productive due to all the nutrients that had accumulated over hundreds and thousands of years. As we move forward in time and those nutrients were used up, these farms became more and more expensive to operate, partly because they were constantly running pumps to keep the fields dry enough to grow crops in. These areas wanted to be wet. They wanted to be wetlands. As a result, the space that became the I-MMAS Preserve started changing hands, and the Nature Conservancy was able to acquire that property, as I said, in 2000. At that time, they began planning the process of restoring it after 80 or so years in agriculture. They seeded roughly 600 acres of prairie, where we get some researchers out doing some work there. They planted a few 100,000 native trees, and they stocked the waters with 31 species of native fish. Birds, mammals, and other wildlife returned on their own, as did a diversity of aquatic vegetation. Roughly 25 years later, the restoration has by and large been very successful. It, of course, needs constant monitoring and management, some of those things we saw about earlier, in order to deal with invasive species, changing environmental conditions, especially with things going on with rain and how our precipitation keeps changing up from year to year. In meeting with groups, when I have them out there in the preserve, I give them that history of the area and discuss some of the kinds of projects that we engage in to help with the restoration. So that really quickly is the I-MMAS Preserve. The next thing that I mentioned we look at macroinvertebrates. If you don't know, these are a diverse group: insects in larval and nymph stages, juvenile forms generally, snails, crayfish, worms, among other things. One of the biggest things they do is they help with decomposition of organic matter and nutrient cycling. They help with the transfer of energy, as these things are all really low down on the food chain, so they provide meals for those fish and ducks that we like to see passing through the area. They're also great water quality indicators. While some are more sensitive than others to pollution and excess nutrients, they spend their lives immersed in the water, and so their diversity and abundance really is a good indicator of how healthy the aquatic system is. If you're living in the water continuously, you're going to be disrupted if things get too bad out there. That might in part answer why I have groups of people wade out there in the water and look for macroinvertebrates. As I said, they're really useful water quality indicators, and so that's one reason we like to study them. Another reason that I like to have non-scientists in particular look at macroinvertebrates is they're very small. They're unfamiliar, they're a little bit strange. A lot of them look like things that were used as models for aliens in movies. The fact that they're small and different means that we really need to pay attention to notice what we're seeing, especially if you want to figure out what their species is and what you're looking at. This one on the left is a caddisfly larvae. You're seeing his or her head just poking out there on the bottom. They make cases and live inside them when they're in these juvenile forms. Depending upon the species, these cases might be made of different materials. This one is made of vegetation and plant matter, but some will use small grains of sand and other bits of rock and debris. There's no scale in the photo, but this would be about the size of a broken piece of lead from a pencil. The middle photo there, that's a water mite. It's about the size of a period at the end of a sentence on a printed page. Some of these critters are amazing. The reward for finding some of these small ones is just to see what they look like and try to figure out what they're doing. Another reason that I like to draw attention to these critters is that they're not necessarily what people think should be in water. For some reason, most people want water in nature to look like filtered bottled water, clear with nothing in it. For many people, their first reaction when I show them the water and show them the things in it is that's gross. They don't want to think about bugs being in water, especially if it's water that they may have swam in the past or where their drinking water comes from in the present moment. Usually, though, as we talk, I'm able to convince them that we need all these different types of life in the waterways and that we want waterways that support life. I always tell them personally that I would be far more afraid with water with nothing in it than water that just has a few bugs living amongst it. All right, so that's the I-MMAS Preserve and a little bit about macroinvertebrates. With students, and again, I mean students of all ages, whether they're 15 or 80, we talk about the preserve and the value of the macroinvertebrates. Generally speaking, students, people listening to me, they nod their heads and they sort of stare at me for a while. It is then that I explain that they'll be helping us out with examining these critters in the wetland, trying to evaluate how this restoration project is going. I introduce them to waders. Most people have never worn them before, which I suppose is not too surprising, but again, it's this connection with your natural environment. I demonstrate how to use a D-net that we use for sampling, then get them outfitted and set up to go make some collections. And we then march down to the shoreline. There are always at least one in the group, usually more, that look at me like I'm crazy, and they seem to say walking in water and touching bugs is not why I'm here, not what I signed up for. Eventually, though, they always all get out in the water. There are occasionally shouts and always lots of laughter as those new to waders and walking around in the mud stumble a bit and get their feet stuck. After a short while, most people have gotten quite comfortable, and they start wandering around and begin collecting samples, looking at what they see in the water. Many doubt that they're actually capturing any of the macroinvertebrates we have them look for, and as I point some out in their nets, they're usually a little bit shocked about that. I know it doesn't take a lot of effort to find things out there for our purposes. The wetland's in great shape. These life forms are really abundant there. When I direct them to head back to shore, there are always some who linger, particularly enjoying being out there in the water. And this was particularly the case when I had some of U of I's upper administrators there as well. They didn't want to get out. Oops. So once we're back on dry land, we show them how to start picking bugs out of their samples and give them a jar to put things in. Again, there's always a few this is gross kind of looks coming from the students I'm working with, but soon silence falls over the group as they focus, only occasionally being broken by an exclamation, something like, "Look what I found." It never ceases to amaze me how quiet some of the groups get when we're out there. Sometimes all I can hear are actually all the birds out in the wetland. As I walk around and help them, all I see are sets of heads bent over the sorting trays. Some of the same people who earlier in the day could not imagine intentionally touching a bug have their faces down in the trays. Noses are usually nearly touching the water. It's really, really pretty amazing how they've changed just in a short time there once we get them out in the water. When I tell them it's time to pack up so we can head back to the lab, I'm usually greeted with grumbling. They haven't had a chance to look at everything. Some of the larger critters, they have actually named them, usually nothing scientifically, but things like Fred or Bob or Ben. And their owners are really eager to look at them under the microscope. Back in the lab, we teach them how to use our microscopes and how to look at these bugs. We teach them some basic IDs, discuss different features that they should be looking for, the antennae, the number of legs, how the joints are, all these good things, development of wings. As it comes up in discussion, some of the natural history will also be shared with them as well. I think the fun parts really begin when I start borrowing some of their finds and putting them on my microscope, which is connected usually either to a big flat screen or to our projector. So the bugs look absolutely huge up there. This is when cell phones often come out, and this is probably the only time I'm happy seeing the cell phones come out in the classroom. And that's because they're taking selfies with things like dragonfly nymphs or whatever critters up on the screen. They're sending these to their friends, probably bothering them in a class they should be paying attention to. But they're really getting excited and they're wanting to capture what they've seen and what they've found. Everybody in the room is usually smiling, getting lots of questions from all directions as they want to know everything about the bugs they found. Even the people who doubted this activity and gave me suspicious looks when I said we're going to look for insects have really come around during these opportunities. We get lots of great feedback from all the students who go on these trips. I've had older students tell me that if they had experiences like this when they were in school, they likely would have taken very different career paths. Here's a selection of some of the comments high school students have sent to us. I'm not going to read through them all. You guys can look at those up on the screen. One of my favorite, though, is this first one. My favorite part of the trip was how hands-on it was. I really enjoyed being able to actually do this stuff while learning instead of just learning it. And so these are these types of comments. It's the same theme that we get in all the feedback. Sure, I selected ones that I'm a little bit biased to, but this is broadly speaking the feedback we get. People really enjoy these experiences. The students really enjoy the experience. They feel that they learn a lot more because they're having these hands-on opportunities and they're thinking differently about these environments because they got to go out in there and they got to take part in some of these collections. So where do we go next? Citizen science projects, things like eBird and iNaturalist, you've probably all heard of. They've been pretty successful. Both have been able to supply useful data in different research projects, and both have successfully captured the attention of a portion of the non-traditional audience for those things. I'm working with a graduate student right now to compare quantitative data that he will be collecting with the non-systematic qualitative data that we generate with these field trip groups. One of our goals of this is going to be able to see how we can extend the value of these field trips beyond just the experiences. This will help allow us to conduct more monitoring and hopefully improve our understanding of the macroinvertebrates both within the preserve and in nearby areas. I'd like to think that knowing that they're contributing to our research will increase the value of these experiences for the students, though it might be that the experience alone is all the value that they really need. So back to how do we enhance ecosystems? Bringing it back to all that slide from the beginning, these activities are sort of traditionally thought of what scientists do. And I think all of these, as I said, they're important, they're necessary. But what I hope I've done today is draw some attention to a way of enhancing our aquatic ecosystems that's often overlooked. That's providing the experiences related to the ecosystems we value, not just transferring knowledge. I'm certain that the students we have helped gain experience in the preserve will think back fondly on their time in waders, carrying a D-net and stumbling in the Amaquan Preserve. I think they'll also trust some of the knowledge that scientists do try to share with them because they've had this experience of doing and seeing what's out there. Not all research lends itself towards providing experiences for the general public, and not all researchers are comfortable doing that. But I think those of us in fields where it works, we need to keep this in mind as a tool for connecting people to the environment and the places that we care about if we truly want to see future change. So thank you, and I can take any questions if we have time.
Thank you very much, Dr. Rothfuss. We have a couple of questions. We have 1 minute. So in this aquatic system, have you had problems with invasive species, and have you developed biological control projects?
Yeah, so probably the biggest one that people think of in the Midwest would be the various species of Asian carp. And we do have some of them in the Amaquan Preserve and in the Illinois River in particular. Our partners with the Nature Conservancy are engaged in a variety of different projects trying to control for the carp. There's some trapping projects. There's some testing of different types of barrier systems to keep them from moving in the rivers. So a fair bit going on with that. My work tends to be with there as we get those researchers working at our facility, and so they're making use of our lab spaces and other things for that.
Yeah, briefly, there is another one connected. Is curious to learn from your experience on impact of invasive alien species brought in by river interlinking projects, especially since we are now trying to address the reuse, recycling water. How important is it for engineers to work with ecologists in conservation of native species, both flora and fauna?
Yeah, I think that's a huge thing. The transport of water that we commonly get in ballast in ships, especially in the Great Lakes, but moving up and down places like the Illinois River has been a persistent issue. As mentioned, it brings in one thing we often overlook are all the seeds from different plants that may be transported in those ways. We also overlook larvae. Zebra mussels were a big issue in stretches of both the Great Lakes and the Illinois River. And so we do have invasive mussel species that have been maybe making things harder on our native species to recover. All these things I think we have to keep up in the forefront. And I think one of the big things, again, with the type of work that I do with interacting with the community and the public on this is increasing their awareness of these things. We can tell fishermen who are going out into the preserve all we want about making sure they're washing their boat and preventing non-native species from making it into the preserve. But if we don't actually provide some examples of how this is hurting the fish, how this is affecting the things that they care about, I think we're always going to struggle with those issues.
Thank you again, Dr. Thomas Rothfuss, University of Illinois Springfield, for your wonderful presentation. Thank you.
Thank you.
Okay, very good. Now we have a 10-minute break for you to take a look at the bios of all our speakers in a show PowerPoint presentation. Please don't go anywhere. We are looking at the bios, and immediately we're going to start again with Dr. Marcelo Garcia presentation. So just few minutes, 7 minutes, I guess we have. Thank you. Okay, very good. Welcome back. We will continue with the symposium. And now it's my great pleasure to introduce Dr. Marcelo Garcia. He is the MT Jeffrey G. Endowed Chair in Civil Engineering. He is the director of Ben Cho Hydrosystems Laboratory and professor at the University of Illinois Urbana-Champaign. Dr. Garcia, thank you for sharing your slides with us.
All right, thank you, Elvira, and good morning, everyone. Let me see if I can share my my slides.
Yes.
And
Yes.
no, this is not what I want. Are you seeing my slides now?
Yes, 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 I can see
Okay,
them.
well, good. Yeah, well, good morning, everyone, and thank you for the opportunity to speak to this in this symposium. I was just checking in my office and my studio here at home, and I found a little certificate back in 2006, about 20 years ago. I gave a talk at the Instituto Mexicano de Tecnología del Agua on the occasion of the 20th anniversary of the institute in Morelos. And at that time, I talked about the title of the talk was Hydraulics in the Times of Cholera. And I was talking about Chicago in particular, and that's what I'm going to do today. I changed from talking about rivers to talk about Chicago and the system and essentially how it works. And so the history of Chicago, there was already one of the presentations by Rachel, I believe, that talk about the basically Bubbly Creek and some of the issues with the canal and the challenges that we have. But for about 20 years now, we have been working on trying to understand what is the impact of precipitation in the Chicago area, and trying to push for the creation of a water observatory that would allow us to um, let me see, how can I get rid of this? Let me see if this helps. So that would allow us to essentially manage the system a little bit better. So one of the biggest challenges is urban flooding. And urban flooding, it's it's a big issue, in particular in large cities. You know, there are estimates that says that the cost of dealing with flooding in large cities like Chicago, Mexico City, is going to reach on the order of $52 billion for by the year 2050. Okay, so um, in Chicago in particular, Chicago has the issue that it has combined sewer system where the rainfall sewers, where you take the runoff and the sanitary sewers are combined, and that historically has generated a lot of problems. But there are a lot of vulnerable communities. As you can see here in these pictures, this was storms that happened around 2013. But if you look at data, the claims um, for insurance related to flooding have skyrocketed over the years.
Oh, sorry,
And
I don't think your slides are moving. I just see the first one.
they are not moving. Let me see.
I believe you are
Let
sharing
me
the
let me
PDF.
let me stop share and try again and
We
see
can
if,
share it if you want.
do you see them now?
Yes, yes. Try to
Um,
move the next one. Doesn't move.
Yeah, the problem that I have is that I can't get rid of, let me see.
Okay, now we're fine.
Can you
Next.
see them?
Yes, next. Okay, now is the floating one, urban flooding.
Okay, so I was talking about the challenge of urban flooding, and this in Chicago has been a perennial problem, okay? Particularly on the south side of Chicago, right? That it's an area that has a number of challenges, but flooding has been one of them. Okay, so what you can see is that it's not just the impact of on households in terms of just flooding of basements, but also it presents a lot of health risks, and that in itself is it's a challenge. And I apologize because I know that this is getting out of whack here, and so what is it that we have been trying to do over time? Well, we have been trying to do how the system works, but there are some critical knowledge gaps, and those knowledge gaps are associated with lack of data, lack of observations. This is a Wilmette, and you can see that here the system is overflowing and water is getting back into Lake Michigan, and that for many years was a big problem. So there is a need, in order to protect communities, there is a need to have more information, but also there is a need to have models that can allow one to predict and manage the system. So here, what you see is the amount of stormwater released into Lake Michigan up to 2013 in billions of gallons. And as you all know, the Chicago River was reversed with the idea of using Lake Michigan water to dilute the water that was coming out of the city before wastewater treatment plants were built. So, okay, so for many years, when the river could not take all this water coming out of the city from the combined sewers, basically the water went into the lake. The good news is that Chicago came up with a way to capture the water by building underground storage, as we're going to see. So this gives you an idea about the impact that flooding has on claims, basically, um, associated with extreme rainfall events, which are a lot more common these days, both in intensity and duration. So you can see that millions of dollars go into recovery from flooding, and this is essentially claims by zip code, and you can see that there are many claims. So what we have tried to do now for quite some time is try to come up with observations of flooding conditions, of rainfall events, distribution of rainfall, and try to see if we can come up with a way of helping urban communities and the city, of course, and MWRD, which is the main agency involved in stormwater management, and try to increase flood resilience, basically. Okay, so what you see there is a map of rainfall, the cityscape, combined sewers, interceptors, and then TARP, where TARP is the tunnel and reservoir plan, which is a way that uh, the Chicago area has dealt with this. So the idea of this system is that you build tunnels, okay, under the city, and those tunnels basically they hold the water until the storm goes away, and you pump that water back to the wastewater treatment plant, and then you put it back into the river and the canal. So before TARP came along, essentially when the wastewater treatment plants could not take any more water, uh, the water just went to the river, and that was when you had a lot more pollution that you have now, and you have to open the gates and go into the lake, which is the main source of water for the Chicago area. So the TARP system started to be built in the 1970s and is still under construction today, and it has 160 kilometers of tunnels plus reservoirs that are connected to it. So what we have been working on is developing this model that we call MetroFlow, and the idea of MetroFlow is to try to put everything together so that this model allows to basically manage extreme flow events in a better way, and also makes it possible to incorporate green infrastructure as you keep changing things, with the idea of trying to reduce the impact of stormwater and improve, just not hydraulic conditions, but also water quality, basically. So it's just a quick overlook to give you an idea of how we deal with rainfall. And this is something that has taken a lot of work, just getting the physical information into a way that you can develop these hydrologic and hydraulic models. But the idea is that we take the rain and we basically route the rain through the system. And what you see there is basically how things get passed through everything, basically. So the water that can go to the treatment plants during a rainfall event, they keep going, but when the treatment plant cannot take any more water, that water gets dropped through these drop shafts. And there are about 300 of these drop shafts. These are like 100-meter tall structures that drop the water into the underground, and the water is kept there, connected to reservoirs. When the storm goes away, you pump it back to the treatment plants, Stickney, O'Brien on the north side, and Calumet in the south, and then you put it back into the river. So as you can imagine, modeling all this, what we call a dual drainage model, that you model the rain, what happens at the street level, and then the interaction with the sewers, taking into account soil infiltration and a number of other conditions, it's quite an undertaking. The main problem of Chicago, like I said, is the fact that the sewers are combined. So when it rains too much, as you can see in this picture, the sewers the capacity of the sewers will be overwhelmed. So if you're not careful when you're trying to use the facilities in a home, the water basically will not drain towards the sewer, but on the other hand, it's going to go on the other direction. So what is necessary here is to have backflow preventers, basically, that allow you to prevent the water from flooding your basement or parts of your house. But this is a problem that is very, very common. So what we have been striving for is to try to have a network of sensors as well as crowdsourcing to be able to figure out what are the conditions that you see on the streets. And sometimes, even though on the street it looks like there is no flooding, underground there is actually flooding, and this is obviously it's an issue. So there is a clear need to implement a network of sensors that you can monitor the water, and people can also inform about this, and so that the system, the storm flow monitoring, can be used basically almost real time to try to predict what are the conditions and manage the system and prevent flooding, increase resilience. And this is a common problem for large cities. So this happens in Mexico as well, that you have, this day and age, there is events, rainfall events that really cause a lot more problem than they did in the past. So the idea here is to try to eventually have a real-time stormwater management system that can allow us to predict on the run what is going to happen with using radar data and so forth. But obviously, you cannot capture every storm. So the idea is that you can train machine learning models that can give you a universe of conditions of different storms, so that when you do get a storm of certain characteristics, you input that data into your models, and you know how to operate the system to minimize flooding and the impact. So one of the things that have been proposed is to try to turn Chicago into what we call a sponge city, try to increase green infrastructure like green roofs and gardens and so forth. But what is clear is that while this helps a lot and you help mitigate the urban heat island effect, this is not enough in front of the events that we are having these days, which are a lot more extreme and a lot more often. Okay, so one of the things that we need to look into more is more community education. One of the proposals that we have made has been to create this hydrologic cycle simulator that we can have in Chicago, where DPI is, the Illinois Center, the Alumni Center as well, where you actually try to educate about the hydrologic cycle in the city and what is the interaction of with the waterway system each time it rains, Lake Michigan, all the way the flows, the excess flows that go into the Illinois River. The previous presenter was talking about the impact of that Chicago has had also on the Illinois River over the years, and then all the way from the Mississippi to the Gulf of Mexico. So I end with that, and happy
Thank you.
to entertain any questions.
Thank you, Dr. Garcia. We are going to have the questions at the end of this session of water
All right.
resources. So we'll continue now with the next speaker. Thank you very much.
Thank you.
Thank you. Our next speaker is Francisco Turner from Water Quality and Water Pollutants Removal Lab. He's the coordinator. He's from FES Iztacala UNAM with his talk, Domestic and Industrial Wastewater Issues at Mexico City. Please, doctor.
Thank you. Thank you very much. Let me share. Okay. A minute. Can you see my presentation, please?
Yes.
Yes, doctor.
Okay. Can you see the change of the slides?
Yes.
Perfect. Thank you. Okay, thank you very much. We're going to talk about domestic and industrial wastewater issues at Mexico City. Thanks to the University of Illinois System for this opportunity, this symposium. Very interesting, all the topics. And okay, the subject of Mexico City is its large inhabitants quantity, 22 million inhabitants. It has a very stressed aquifer that in fact we need to bring into the city the 30% of the water supply. It's a historic Kutsamala system. It's a water supply system that comes from the west of the city, passing through several dam systems and passing through a water treatment plant, Los Berros treatment plant, which is the potable water, potabilization water treatment plant. And it goes a long way, even not only in kilometers, but also in altitude, to overcome different sierras along the way. So the pumping system that this Kutsamala system needs. It needs to overcome almost 1 kilometer of altitude, and this is a lot of energy that is spent to keep the city functioning around the amount of water that it needs to run and to function properly. So, so our dear Mexico City is a city that is very expensive on maintaining because of the water that needs to be bring in, but also the wastewater that needs to run out the city, because actually we have a system that leads all the water to the north, all the wastewater to the north. So fresh water comes from the west, and wastewater goes to the north, historically, to this place that we call the Mezquital Valley, Valle del Mezquital. The Mezquital is the name given because of these very short trees that are very common in Mexico, that are trees that grow in semi-arid areas of Mexico. So the Mezquital Valley used to be a significantly arid valley until Mexico City decided to bring out all the wastewater to that area. So the wastewater goes a long way to the north, passing through different water areas like Zumpango Lake, like Endo Dam Lake, Riquena Dam, and through different tunnels that are bringing out the water from the city. So the hydric balance of the city is always negative, because since 30% of the fresh water comes from the outside, the rest from the wells that are still in operation within the city. But the most of the water, around 90%, 85% of the wastewater is taken out of the city. So our even in the rainy season, all our aquifers are overexploited. So that's a problem. This is a picture. This is a picture from the Mezquital Valley, which, given the fact that it has received large amounts of wastewater since the beginning of the 20th century, the district has become a very successful agricultural district. So the amount of water that has entered this valley has been so huge that from many decades back, it began to appear different springs of clear water. So it's not only an agricultural district, a successful agricultural district, but also is an area which has a lot of springs. These springs are used by the local communities as regular fresh water supply. So that's an issue. Sorry. The other issue about the wastewaters in Mexico is that our national wastewater generation estimated in 400 cubic meters per second. Mexico City itself produces around 50 cubic meters per second, almost 100 cubic meters per second in the rainy season. And our treatment capabilities are still not the best. Across the years, you can see this graphic from Conagua, our main water administration organism. You can see we've been having an important increasing on our wastewater treatment capabilities, yes, but there's still work to do. Okay, we have 2024, and we still have 30% of our wastewater is not treated. So in 2015, a new player came to the system of water management of Mexico City, since in the very investigated value, it was installed one of the largest wastewater treatment plants in the world. This Atotonilco wastewater treatment plant manages around 50 cubic meters per second. It has a lot of, you can see in the back of the picture, a lot of these yellow structures that are actually anaerobic digesters for all the sludge that is produced from all the treatment that is occurring in these plants. Of course, this plant is very large, but it uses still very conventional systems like activated sludge or primary chemical treatment. Okay. So the main challenges for our country, but also for our area in Mexico City, is the increasing of scarcity of the sources of fresh water. You can see the map of our country, where you can see the center of the country with in red all the areas, all the basins that have overexploited aquifers. So we have 1/4 of our national aquifers overexploited. Also, 40 million people live in water supply stressed regions. And of course, it is not casual that the main overexploited aquifers are in the main areas where the largest urban areas are, but also in the border area. To that scarcity, we have to add the pollution. We have to repeat, we don't treat around 30 to 40% of our wastewater, and the climate change impact of our hydrological cycle is evident. And of course, we have the problem of inefficient management. Many of the wastewater treatment plants in Mexico are in a very low efficient operation, or in some places are even abandoned completely. So this is the horizon of water in Mexico City, with the water administration began different programs in the decade of 2010. The water administration began programs to try to explore the possibility of treating the wastewater to the point of producing fresh water out of the wastewater. So to potabilize all the wastewater. Okay, so they begin with an attempt of a pilot plant with reverse osmosis, coupled to a conventional activated sludge at the Iztapalapa, Cerro de la Estrella Iztapalapa wastewater treatment plant, that was managing at that point 2 cubic meters per second, which is very low amount compared to the 15 cubic meters per second that is managed in the entire Mexico City. Still, these attempts were thought to thinking on the possibility of a reinjection of treated wastewater to the aquifer of Mexico City. This is a project that hasn't been really put in place yet, but it's one possibility that has been over the table, given the very stressed aquifer that we have in the city. In our case, in our lab, we've been having projects focused on precisely what happened if this wastewater, this treated water, could become at some point drinking water. And one of the issues, very important issues on this, is the presence of the micropollutants, because although we have the capability probably to remove most of the organic matter and nutrients with conventional systems, many of the micropollutants remain unless we use advanced treatment systems. So we've been working on membrane systems approach with lab scale assays, but also with field assays, trying to measure the capabilities of different membranes to remove different micropollutants such as hormones, phenolics, endocrine disruptors, pharmaceuticals. You can see here different pharmaceuticals. You can see here some of the main endocrine disruptors that, like phthalates, this bis-acetylhexyl phthalate and butylbenzyl phthalate, also BPA. So we've been trying some field pilot plans. On this pilot plan, for example, was put in place in the Cerro de la Estrella Iztapalapa wastewater treatment plant using their domestic wastewater to determine the capabilities of nano filtration membranes to remove these micropollutants. Fortunately, the membrane technologies are consistent. Sometimes you can see in the orange line, the orange line indicate the percentage of removal of these micropollutants by the conventional activated sludge system. And you can see with the nanofilter, the nanofiber membrane, that most of the micropollutants can be removed more thoroughly. Okay, so we've been working with these kind of systems, trying also in trying to determine how feasible would be that the installation of these advanced membrane systems might work to potabilization of wastewater from Mexico City. We also work at the springs at Mezquital Valley and install these nanofiltration systems to determine the amount of original micropollutants in the springs, but also the percentage of removal. Fortunately for the most of the inhabitants of those communities, the spring water in those areas had not any of these micropollutants present. The most of them were below the limit of detection of our techniques, and our techniques were able to detect nanograms per liter. So, but we did detect some micropollutants in let's say small scale, like nonyl phenols, like salicylic acid, some phthalates also, and the membrane was able to remove a significant percentage of them. So probably spring water is well, the main thing is that the local soil at the Mezquital Valley was actually able to remove a great amount of the wastewater micropollutants. So it's a great filter and transformer. However, what about all the metabolites that we cannot see? And is the spring water enough to become a future water source for Mexico City, or let's say a trustable water source for nearby communities in the large term. We don't know yet, but we do know that we need a complete inventory of these springs, so we can be able to determine if this might be a future water source for Mexico City, because actually the city is now looking for new water sources, since rainy season, no matter how climate change over rainy season we have, the aquifer recharge is not enough. So talking about the possibility of saving water, we have to, I'm going to go back a little bit. Just very fast.
1 minute.
Oh, no. Okay. In this very north area, we have also a lot of industries. So we've been working with those industries, which are mainly textile wastewaters, and we've been addressing different other projects like improving their biological systems with polymeric biomass carriers, with tertiary microalgae systems, and trying to determine if a multi-industry approach would work for these wastewater plants. Also, the internal reutilization of textile wastewater is very important and has saved a lot of water. So another projects we have in our group is are like the treated of hypertrophic urban lakes. So my colleagues will talk about later with biofilm systems, and we have a project currently funded by CECITI, which is a Mexican science and technology fund from the government. And finally, I have to give a commercial of other of my colleagues from my group. We have ecotoxicology projects. We have also projects on following biodiversity, bacterial biodiversity on all our projects with our massive sequential system in Fezistacala. And we also have research areas like amoeba systems, trying to identify and characterize pathogenic free-living amoeba, especially Nigeria fowleri, and other projects with the Bill and Melinda Gates Foundation, like Helminth X identification systems. So I want to thank everybody from our team, also our team in Water Quality Laboratory, and all our students. Thank you very much.
Thank you very much, Dr. Turner. Will be time for questions later after the next two speakers.
Okay, glad to answer the question. Thank you.
Moving forward, we have now Dr. Krishna Reddy, Professor, University Scholar, and Distinguished Researcher, Director of Sustainable Engineering Research Laboratory and the Geotechnical and Geoenvironmental Engineering Laboratory, University of Illinois, Chicago. Thank you, Dr. Reddy. Please share.
Hola.
Hola.
Hello, everyone. So my name is Krishna Reddy. I'm a professor of civil and environmental engineering at the University of Illinois, Chicago. I want to thank the organizers for inviting me to present in this symposium. So my presentation title is Integrating Artificial Intelligence in Contaminated Site Remediation, and I'm going to focus more on remediation of polluted groundwater. So I'm in charge of these two labs, and we work in our lab on environmental remediation of soils, sediments, groundwater, and stormwater. We also work on waste management and landfill engineering, and we work on life cycle assessment and sustainable and resilient engineering. We work on geotechnical engineering, mainly from a civil infrastructure point of view. So if you are interested in knowing about our research. So please feel to look at these websites. So talking about contaminated sites, there are many sites that are contaminated. Soil and groundwater is contaminated at these sites, and it's invisible, and it's a huge problem. And there are many sources of contamination. I listed many of them, and one of the major sources of contamination is land disposal of solid and liquid waste. And in the US, we have a good estimate on number of sites. We have thousands of sites, and it's going to cost a lot of money to clean up these sites. So you have a similar situation in Europe, and also other developing countries have a lot of these contaminated sites that needs to be cleaned up. So when you talk about contamination, what is contamination, right? What is contamination? You can see, this could be inorganic contaminants, heavy metals, radionuclides, or organic contaminants like PFAS, which is a very big problem these days. And you have all these other organic compounds, as our previous presenters presented, even microplastics is a big problem. So you could have other issues like pH, nutrients, biological contamination. These are all problems because they pose toxic impacts to humans and also to ecosystem. And when we talk about groundwater is a valuable resource, and we must protect it from contamination because it is the sole source of drinking water for many people all over the world. So in the US, USGS and other agencies have done a good job in terms of identifying aquifers that have been contaminated. So these shows the aquifers that are contaminated across the US. Contamination could be natural geological sources or from human sources. And even in Mexico, it seems the groundwater is contaminated with a lot of these contaminants that exceeding the levels. So we need to clean up groundwater because, contamination from the groundwater could be exposed to people by different exposure pathways, and it could cause unacceptable human health risks and also risk to surrounding ecology. So there are a lot of technologies to clean up contaminated groundwater. These are a few technologies that we worked in our labs. And if you want to know more about these technologies, you can go to these resources, find more information about them. But the problem is, the selection of the remediation technology depends upon many factors, like a site characteristics, soil characteristics, groundwater characteristics, contaminant characteristics, and what are your remedial goals? What is the cost, financing, time for remediation, and what is the end use of soil or groundwater? So all these factors have to be considered in selecting the remediation technology. And moreover, when you are designing a particular remediation technology, you need to consider site-specific contamination and local geological and hydrogeological conditions. And there could be many variations in selecting the system components. And there are many variables in design and operational parameters. There are many different ways that you can implement this, implement the remediation. And there are many variables in deciding the monitoring requirements. And you want to monitor and also may want to adjust your system. That's optimization. That also depends. And all these aspects add a lot of complexity and additional costs, time, resources. For anybody who is working in the remediation field, they know this problem. So this is a huge problem. So in this context, can artificial intelligence help? So in fact, it can. If you look at contaminated site remediation, there are different phases of contaminated remediation projects. And in each phase of these projects, AI could be useful. And there are a lot of AI approaches, models, tools that can be used. And it can be used for spatial distribution of the contamination, to develop the decision support tools, to have a simulation of optimization, or you can have a data-driven modeling. So all these things, have a possibility to achieve. And many of you know artificial intelligence. Basically, it's the theory and development of computer systems that can perform tasks that normally require human intelligence. There are a lot of different types of artificial intelligence methods that can be, or tools that can be used. But most of the times we try to use machine learning and deep learning models. And as you see, these models are evolving at a very, very fast rate. And we have published recently a review paper, and we published a few papers on using AI in our site remediation projects. I recommend you to look at these papers for the background on different AI methods. So I want to show you quickly two case studies on how AI is being helpful in contaminated site remediation projects. So this is the project in California. So they have done extensive groundwater monitoring and testing to look at PFAS concentrations across this California. But you can see that there are areas where information is not available. So this AI/ML model is used to predict the concentrations in the areas where the data is not available, and also use that data to prioritize the locations where they could go and drill wells and monitor. So kind of using the AI as a guiding tool to look at the locations where they can actually go and put in wells. So for the development of this AI model, they used all the existing PFAS concentration data. They also used the nearby airports and also hydrologic features, the 14 of them, and soil features, 16 of them. And they also looked at any kind of correlation between the coexisting contaminants versus there are PFAS. There are many types of PFAS. If there is a correlation, indeed, they found some good correlation between some contaminants and the PFAS, as you see from here, and some didn't have any correlation. So they used all this data to develop a AI model, and it has a reasonable correlation. And with that model, they were able to predict PFAS concentrations in the areas that they didn't have the data before. So with this information, so you can actually, select the locations where you want to drill the wells and collect the samples to know, you don't want to depend upon this AI model, but you want to go and do actual sampling. So this AI model is actually helping us to select the rational locations. So instead of, otherwise you would have probably put in 1,000 wells. Instead of that, with this AI model help, you can reduce the number of wells. That can save the time and the cost. So this is an example of how AI could be used in the site characterization. Quickly, I want to show you the second case study. This is the site where groundwater is contaminated by TDS. And proposed remediation plan is to have a pumping wells and then pump out all the contaminated water and inject into, treat it, and then inject back into the aquifer again. So the question is, they have these series of wells, that the extraction wells, pumping wells, and the injection wells. The point here is, how much water you need to extract, what pumping rates, what should be the injection rates, right? So that, we can efficiently reduce the concentrations in this aquifer. So here, AI came into use. So they use these, common models, SmartFlow and MD3D, and they consider different scenarios. And they use that data to develop this AI surrogate model. And this AI surrogate model is shown to have good correlation with physics-based model results. And then with that model, AI model, they use this optimization scheme and they had 9 injection wells, and they were able to recommend the pumping sequences, how much pumping rates and what times in each well. They came up with this sequence. So with this optimized sequence, prediction is that contamination is going to reduce very efficiently in a reasonable time frame. So this again, provided, instead of not knowing how to operate these injection wells and extraction wells, so this AI-based approach, helping to optimize the injection and extraction and injection systems to efficiently, remediate the site. So in closing, I just wanted to show you AI has a great potential for informed decisions at all phases of groundwater remediation. AI-based optimizations can promote improved efficiency, time, and cost savings. However, there are a lot of challenges in terms of using AI, right? So first of all, you need to have some actual data to train the models. And if you have a limited amount of more data, then you may be running into overfitting of the models. And the other problem is a lot of professionals who are working in this area, they are not knowledgeable about AI, so they need to be trained. So also, we need to incorporate a lot of field scale remediation data into databases and train the models. And we need interdisciplinary research and educational activities so that we can promote a lot of AI use in remediation projects. So I went through quickly, but there are a lot of opportunities for collaboration in this area. So if you are interested in working with us, this is our contact information. Feel free to contact us anytime you like. Thank you so much.
Thank you very much, Dr. Reddy. Okay, we have several questions that are being answered in the Q&A. So if you agree to continue answering the questions in the Q&A, we will move forward with the next presentation. Thank you so much, Dr. Reddy.
Sounds good.
Now we have Dr. Chaparro.
Next up, we have Dr. Diego Chaparro. He's a professor from Aquatic Microecology Lab, and his presentation is titled Mexican Aquatic Systems Restoration and Their Biological Diversity.
We cannot hear you. We cannot hear you. Dr. Chaparro, we cannot hear you. Yeah, I think Dr. Chaparro is having some technical issues here. I cannot see your slides or I cannot hear you. Are you muted? Okay, so as he comes back, as Dr. Chaparro comes back and shares his slides, we have time if Dr. Krishna Reddy wants to answer one question. Are you available, Dr. Reddy?
Yes.
Yes, it says, would you suggest any specific ML models for groundwater remediation or leachable treatment?
So there are a lot of models. I don't think that there is one particular AI ML model that universally applicable for all the scenarios that you come across. So look at the problem that you have, and also look at the data that you have, and there are a lot of ML models and DL models, deep learning models, and what is the purpose of your modeling. So make sure you select the model that based on your specific data and the purpose. So there are so many models that you could use it. And as I pointed out, in our review paper, we have summarized the models that you could use at different phases of your remediation project. Site characterization, maybe risk assessment, and selection of the remediation technologies. So there are so many models, and you really need to select the one that best serves your project.
Okay, very good. Thank you so much. So I don't see Dr. Chaparro. We will continue with our next speaker.
And I will, yeah, so go ahead.
Okay, our next
Thanks.
speaker is Dr. Nandini. She's from Aquatic Ecology Lab, and her presentation is Invasive Planktonic Species in Lentic and Lotic Waters. Doctor, please.
Just give me a moment. Can you hear me?
Yes, I can hear you.
Okay. Dr. Diego just asked me to convey to you that he's trying to fix the problem. And
when he comes back, we'll present him. But if you want, go ahead, please.
yeah, I will. I'm just trying to share my slides now. Can you see the slide?
Yes.
Yes,
Okay.
it's now in full screen.
Oh, thank you. Thank you very, very much for this opportunity to talk to all of you about a part of what we work on, a very interesting subject about invasive planktonic species in lentic and lotic waters, obviously with special emphasis in Mexican conditions. I would like to begin with this very, very nice paper presented by Dr. John Downing. It was presented quite a while ago. In 2014, it was published, but it holds true even today. Freshwater, as we all know, is a priceless resource. And then, as now, aquatic invasive species is a huge problem in the second position of water quality in freshwaters. The study of invasion biology is nothing new. It has been going on for almost 70 years in a formal way. Although many, many years ago, at the time of Linnaeus also, there were reports of invasive species in the Americas from Europe. In Mexico, we have several catalogs on invasive species. Conabio has done a wonderful job over here of cataloging all the species in the country. And as we will see, there are numerous invasive species in our waters. The interest in invasive species has risen exponentially, as you can see from some of the data presented here in international and in national journals. The one on the right, I don't know if you can see my arrow. The one on the right is a study published in a journal of Fesistacala. And the rise has been from the year about 2000. The mega diverse status of Mexico is well known to all. There are two reasons for this, principal reasons. Number one, there that Mexico represents a mix of the Nearctic and the Neotropical, and a transition between these two important biogeographical regions. It also is a country with numerous different kinds of habitats. So when you study invasive species in Mexico, we have to be very careful to take a look at this map, which clearly categorizes the regions of Mexico, and then decide whether the species is truly invasive from the Neotropical to the Nearctic or vice versa, or from other parts of the world. That is less of a problem. Conabio indicates that Mexico has about 120,000 species, of which 1.5% may be exotic. Most of these are plants, fish, algae, and protists. Where do these species come from? Aquaculture practices, the introduction of carps and tilapia in several water bodies in the country, has put the native taxa at great risk, especially fish species and other species. Some of them escape from aquaculture farms, for instance, Peneus monodon. It's a huge shrimp, quite delicious, but it was introduced from Asia to Mexican water bodies, and now it has escaped into the natural system. From laboratories, if species are not handled carefully, then amphibians, cladocerans, they all escape into the natural system, as can be seen from this case of Daphnia magna. We'll talk about it more a little later. Ornamental fish trade brings in a lot of different macrophytes, lot of different organisms, invertebrates, vertebrates, and the presence of Hypostomus plecostomus is another great problem in the country. Pristine water bodies are being invaded by this fish, which was introduced to clean aquaria. We all know about the problems of ballast water, increased globalization, which is not going away anywhere. And this brings in many species. Accidents, natural disasters, release from aquarium, for instance. It has been suggested that this is what has introduced the lionfish into the Caribbean. Then natural means, zoochory, anemochory, hydrochory, dispersion of organisms by the wind, by waves, etc., also bring in invasive species. How do we quantify this invasiveness? This table presented by Mazzotti and Briggs-Gonzalez clearly shows that you have to study invasiveness at the population and the community level, and then realize how important the presence of these invasive taxa can be. Simple experiments, laboratory studies on feeding are used quite often. For instance, functional response studies, prey preference studies are used simply to compare the impact that an invasive species may have on native taxa. And here I will now present some case studies on different groups: cyanobacteria, cnidarians, rotifers, cladocerans, copepods, and macrophytes. Let's begin with this cyanobacteria, Cylindrospermopsis. A few years ago, maybe a few decades ago, it was considered a huge problem in Europe when it was first reported. Cylindrospermopsins are the toxins that it produces. These tend to bioaccumulate in fish and mollusks that people eat, and this is a problem for health everywhere. It has a high propensity to spread. For instance, a species, Cylindrospermopsis tavare, was described from Lake Catemaco in Veracruz in 2002. In about 15 years, it appeared in China. Take a look at this one. This is Cordylophora caspia. It's a cnidarium. It's a hydrozoan from the Ponto-Caspian Basin. The Ponto-Caspian Basin, several species are now found around the world. According to Conabio, it is a very high-risk species. We conducted some experiments on it recently and did find that it is a voracious consumer of copepods, may present a huge competition for fish larvae in natural systems. And here we found it in the Tuxpan River in Veracruz. Chelicotia, another species of rotifers, which is widely spread now across the world. Chelicotia is also exotic, invasive to some water bodies in central and southern Mexico. It is a huge problem because this species is even found right up to Brazil. And it could, as you can see from the defenses that it has over here, these spines, it could present important risk to fish larval feeding. Here we conducted some experiments in the river Antigua, which is also in Veracruz, opens into the Gulf of Mexico, and found species of rotifers from China, Lecane yatseni, and from Norway, which is Notolca lipeterseni. The species Notolca lipeterseni has also been recorded in the Hudson River, so we don't really know where it has come from. However, the impact of these species on local fauna has not been tested. Euclanis micropus is another rotifer. We found it in the Antigua River. It probably came in through ballast water because it was first reported in Lake Stecklin in Germany, and it has now established populations. It grows well with less food, so eutrophic waters may restrict its distribution. However, we are not quite sure of it, and further studies are definitely needed to determine whether and to compare it with species from the type locality. Daphnia curvirostris is another species which is found here in the wetlands Chimalhuapan in the state of Mexico. It is a species that we studied some years ago and found that it had low growth rates. No males were found, so we thought that it would not spread. However, we may be wrong because recently we have discovered another population of the species which needs to be studied carefully. And what the impact that this species may have on local fauna, we don't know yet. Daphnia magna, recently reported from the same water body from the wetlands of Chimalhuapan, is another species which we think has escaped from ecotoxicological labs, which frequently use this species to compare their results to data generated from temperate labs from temperate countries, from Europe and United States, for instance. And this species is now found in different water bodies here in Mexico. We don't know what impact it may have on the local fauna. Daphnia lumholtzi, which is native to Africa, Asia, and Australia. It breeds well in warm waters. It is now found in Mexico too. And as you can see over here, the spines clearly show that it may have an important defense against fish feeding. Several species of invasive copepods are found in Mexico. For instance, Mesocyclops pepiensis, Mesocyclops thermocyclopoides, Thermocyclops crassus, Mesocyclops aspericornis. Most of these are from Africa and Asia, and these species occupy vacant niches in water bodies here. You can see the spread of Mesocyclops pepiensis. It was first described in 1940, in less than 80 years. You find it all over the world, including in the Great Lakes. And one of the reasons for this widespread is its ability to feed on even toxic cyanobacteria. So it is a very generalist feeder. It can outcompete perhaps many copepods, especially small native taxa, and it is able to tolerate a wide range of temperatures. If you look at macrophytes in Mexico, you have several orders and species of macrophytes. Many of them are invasive. Some of them were introduced, such as Eichhornia crassipes, and some of them came in through ornamental fish trade, such as Egeria densa or Myriophyllum. Myriophyllum and Dreissena polymorpha, the zebra mussel, which is found in the very north of Mexico. We don't know how long it will take to spread in the country. They facilitate the growth of one another. It is known as invasional meltdown, when two invasive species have a mutualistic relationship between each other, and therefore they help the growth of one another and have a greater adverse impact on the rest of the community. Macrophytes also have indirect effects. For instance, this species, Lythrum, It is found, it's got very pretty flowers, yes, but it attracts a lot of dragonflies. And this species is invasive to Mexico. It attracts these dragonflies, which are voracious predators on zooplankton. So indirectly, it results in a decrease in the density and diversity of zooplankton in water bodies. How can we eradicate population of invasive species, especially that of plankton? First of all, we must recognize the problem. We must work on it to completion. But with plankton, it is more difficult because these organisms have high growth rates and dormant stages. Therefore, it is practically impossible to eradicate them completely. And this makes it very important to study them and to study their impact on local populations. The other problem is that of taxonomists. Taxonomists are, like many species, are also facing extinction. Many people do not want to study the subject, although it is very important for any kind of research in the future, as we all know. Therefore, research and teaching has to go hand in hand. People who are experts must share their knowledge on taxonomy with the younger generation so that they can carry the baton forward. In this regard, we must highlight this wonderful course given by Professor Dumont at Ghent from 1990 to 1998. He trained a large number of taxonomists, and that has resulted in a huge increase in our knowledge of zooplankton around the world. You can study taxonomy by traditional and modern tools, so this should not hinder the attraction of young people to the subject. Monitoring water bodies is absolutely fundamental, especially taking the information after the monitoring studies for the improvement of water quality. But water quality monitoring must continue, especially in water bodies which are important for the use of humans or because of their size or because of the diversity that they harbor. So this presentation, we showed some of the impact of some invasive species, the importance of taxonomy, the long-term monitoring of species in ecosystems, and as many of our previous speakers have highlighted, the importance of citizen science to raise awareness about this subject among students and the general public. Thank you very much. And I think that we will all be taking questions at the end.
Yes, very much. So thank you so much for a wonderful presentation.
Thank you.
Continue with the next speaker.
Thank you. Next up, we have Dr. Miroslav Matzek. He's from the Tropical Limnology Research Group from FES Iztacala with a presentation called Microbial Food Web as a Sentinel of Climate Change. Doctor, the room is yours.
Still somebody is comparting.
Oh, someone is sharing? No, not anymore.
Okay. Just now it's okay. Okay. Good morning to all. I will speak something about the monitoring useful in climate change. First of all, what am I? I am not biologist originally. I am from the applied science branch. I was studying water technology, but my PhD was already done on ciliates, the role of ciliates in activated sludge process, and I was working in Academy of Sciences. And after a short stay in Mexico, working with these artificial wetland treatment plant, I changed to cholera in the environment, relation to ciliates, and from 96 I am already a professor. From 2004, full professor in my part of in our department within UNAM. Okay, let's go. It's very important to study tropical lakes, stratified tropical lakes, because they've got something very different comparing to temperate lakes. Very typically, they possess an anoxic part, and it is something that was not widely studied in the fresh waters. Much more interest is to sea investigations and to the investigation of meromictic lakes. But for monitoring, there are no money anywhere. And then we were financing this monitoring as a background of our scientific programs. However, during last year, we were able to obtain only money for run the projects, but we are lacking more investment to our field instrumentation. Then from 26, we stopped the regular monitoring. But I want to show you what about our investigation. We are working Alchichica Lake, that is endorheic zone of Mexico. There are 6 crater lakes, including Alchichica, Mar-Crater Lake, nothing to do with active volcanoes. Only origin is volcanic. We started to work. It was initiative of Javier Alcocer in the lake. I was incorporated in 98 studying bacteria. The lake is a saline atalasohaline lake with a very nice formation of stromatolites. There below timberline. Originally there was a forest. Just now it's only yucca or molina. Very small amount of real trees. The lake is soda lake. We know very well this thermal behavior of the lake. Typically monomictic lake that is mixed during dry season and lower temperature season in this region. From my point of view, we started to study bacteria, but bacteria generally, the total numbers of bacteria is very boring. Here you can see the profiles and oxygen during the stratification. This hypolimnium is completely anoxic, but what I told already, numbers of bacteria are quite boring. We've got short studies using hybridization in situ method, cart fish also, and recently or during one last decade, my colleagues are studying using Illumina this bacteria distribution. We added autotrophic picoplankton because picocyanobacteria are very important in such types of lakes, but just now they are disappearing from the water column. You can see these during years what was the illumination of the lake, photosynthetically active radiation, and the distribution of picocyanobacteria. You are able to see that during 2005, 2007, the number was much higher than it is typical for now. And from my point of view, the most important and the nicest things are the ciliates, and many of them are related to the anoxic environment. We are not studying taxonomically only. We are interested in the food and feeding behavior of the ciliates, and you can see in protargol staining for identification. You can see the content of the food in the spectrum typical for cyanobacteria and other organisms. It's some huge ciliate spirostomum as well with picocyanobacteria ingested and with algae ingested. The lake was quite conservative in these limnological parameters, and you can see the level throughout the year. medium depths of the limit of oxygen below 0.2 milligrams per liter, and below 2 milligrams. That is this transient zone, very important for microbial ecologists. Quite conservative. Results. We are able to obtain that, as it is typical for oligotrophic lakes, that bacteria biomass within the microbial community is the most important. These Picocyanobacteria has got typical behavior with the maximum just before the stratification of the lake. Then we had very abundant bacteria related to sulfur cycle, Thiocapsa and chlorobium, that both are photosynthetic anoxygenic bacteria in the system. If we comparing with the ciliate, this biomass of ciliate is quite important in the highest importance in the limit of anoxia and below this limit. As well, we define the cycles throughout the year of different behavior of the ciliate in the system. If we plot the same biomass during just in the layer below 1 milligram of liter of oxygen, we can appreciate that the ciliates are even much more important. All these data are quite new for the science, and monitoring from tropical lakes are really very scarce in the literature. But I was showing these median values from 2 decades of our investigation. But in fact, the lake is upon very important stress, this climate stress. It is surface temperature in the lake, the temperatures in the top and bottom of metalimnion. But these changes can be seen much better if we plot this bottom temperature of the lake. Bottom is 60 meters. It was 64, just now it's slightly below 60 meters. And we can see this, how this temperature is increasing. It's comparable to increase in the lake temperature as reservoir temperature in the Central Europe. But during last year, it is even worse in Mexico. But just last year, something has changed in the lake. It was really breakdown moment. And what was typical before for the deep chlorophyll maximum in the lake, to see plenty of diatoms, some endemic Cyclotella alcicicana. There are some ciliates stained with DAPI, Euplotes. And we can see that before 25 and 22, the number of the cyclotellas within the layer between 20 or 40 meter, where this deep chlorophyll maximum is normally centered, that typically there was increasing through August and then low numbers. But in 25, there were only slight peak in the end of July, and then nothing. And cyclotellas were completely replaced by cryptomonads, and cryptomonads appear in huge numbers. They are much smaller from the point of biomass. It is the same as of diatoms before. But these cryptomonads are very typical for the meromictic lakes with anoxic zone. Before, they were not observed. Before, they have got cyclotella, also typical for such lakes, but nothing to do with cryptomonads. Along with these changes, also these autotrophic phytoplankton, mainly bacteria, started to disappear. Before, in this zone, 20 to 40 meters, we had quite constant number of bacteria. Just now it is extremely slowing down. And bacteria with photosynthetic anoxygenic activity has disappeared. In 25, we did not observe anything. Then it's very pity for us that we had to stop this regular monitoring. Why it appeared? One of the hypotheses is connected with the temperature of the zone below oxycline. If we plot the temperature of the layer with 1 milligram per liter, we can see it is not linear increase, even though statistically it's nearly the same. But we can plot it as a quadratic increase of temperature where the oxygen in the lake disappear. When we compare these behavior of the zones throughout the years, we can see extreme increase. When we started it is date from 2004, it was 14.5 degrees, and just now it is over 13 degrees centigrade. And then we can point out some quality of this microbial loop in the lake, but we have a very huge data on the past of the lake, and maybe that some of my colleagues from this seminary are interested in to join us with the analysis of such long set of data from a tropical lake. Thank you very much.
Thank you very much for your presentation. I guess we will continue with the program. And now is the turn for Dr. Erin Bauer. Okay, so Dr. Erin Bauer is going to continue presenting, and it's my great pleasure to introduce her. She's
Hi.
Yes,
I
she's
tried to share, but it said someone else was sharing.
Oh, I don't see anyone sharing.
Okay,
Can you
I will try again then.
Yes, thank you. She is the section lead Water Impact on Society and Environment, Illinois State Water Survey, Prairie Research Institute, University of Illinois, Urbana-Champaign. Thank you, Dr. Bauer.
Hi. I was taking some notes on the previous presenter, and now I need to find my own. Do you see my presentation?
Yes.
Okay. I need to find my own presentation that has the notes, and it's not coming up. Oh dear. It's just digging at me. Why is it doing that? I'm going to stop sharing for a moment. Okay, I hope this is the right one because it's not linking. All right, well, my name is Erin Bauer, and do you hear me now?
Yes, good.
Thank you. My name is Erin Bauer, and I am with the Illinois State Water Survey, located at the University of Illinois. I've been here since 1998, and when my main work was performing lake bathymetry and sedimentation surveys. I now lead a water impact on society environment section and continue to manage several field research projects, including a precipitation network of 19 gauges, stream and river water quality monitoring sites, and artificial floating wetlands research. These sites are scattered across Illinois and the Sangamon, Illinois, and Kaskaskia River watersheds. I enjoy sailing and Sudoku. Although the UVI and UNM FES are separated by thousands of miles and work in very different environments, we may investigate similar water-related processes, share challenges, may connect our research, and ultimately benefit our societies and ecosystems. So to highlight the breadth of research and expertise within the Water Survey, I'll present some brief overview of the capabilities and specialty areas across the survey. Okay. It's not working smoothly, but here we go. The Water Survey recently reorganized into several research themed sections to enhance interdisciplinary research coordination. The Coordinated Hazard Assessment and Mapping Program section performs hydrologic and hydraulic studies for mitigating flood hazards and creating FEMA floodplain maps. The Hydroclimate Variability section analyzes climate impact on water resources. The Hydraulic, Geochemical, and Atmospheric Processes section performs research and modeling on all water resources and provides visualization for stakeholders. Our integrated machine learning and artificial intelligence innovation community aims to advance water research in the ML/AI frontier. And lastly, the Water Impact on Society and Environment section specializes in hydrologic and water quality monitoring, modeling, and public engagement statewide. In the next slides, I will give a brief overview of a few of the current research initiatives and expertise in these sections. So the section I lead is the Water Impact for Society and Environment. And I don't know why this is not joined. So the Water Survey has a broad technical expertise in year-round hydrologic, precipitation, chemical, and watershed monitoring. These observed data are used in various analysis, assessments, research, and subsequent modeling throughout the survey. Current and recent past projects include basin to small process scale studies, including critical zone studies and research, nutrient and sediment transport studies, and artificial floating wetlands research. These monitoring and research efforts provide high-quality scientific data for decision makers so that they can develop and implement sustainable watershed actions. The statewide water supply planning team leads ongoing analysis for near-term and long-term sustainable water supplies and demands with regard to impacts on future economic development and population growth. We've heard some talk about this issue in previous talks today. On one such analysis, evaluates seasonal scenarios for surface and groundwater variations throughout the year across a variety of economic sectors, including the energy sector, and of course the new, data centers that we're dealing with. Northern Illinois water supply is sourced from Lake Michigan and municipal and private groundwater wells. The Southern Illinois water supply sources are mainly from lake reservoirs, aquifers, rivers, and also municipal and private wells. Another research group within the hydroclimate variability section brings extensive technical expertise for research areas evaluating precipitation, evapotranspiration, soil moisture, and crop vegetation conditions for the agricultural community. This work supports drought assessments that support hydrologic system forecasts and guides understanding of potential socioeconomic impacts across the Illinois and surrounding states. This research provides high-quality scientific data and analysis to the community and decision makers so that they can develop and implement sustainable community actions. We regularly collaborate with stakeholders, the University of Illinois, and other universities. In contrast with drought assessment, the Coordinated Hazard Assessment and Mapping Program, CHAMP staff assess flood hazards, identify high-risk areas, and engage community partners to inform, educate, and empower others to take action in preventing losses from natural hazards. We heard about these issues in the Chicago area earlier today. Hazard mitigation plans are comprehensive documents that help communities identify, assess potential natural hazards such as floods, earthquakes, severe storms. These plans outline strategies and actions to reduce the impact of hazards on people, property, and infrastructure by developing and implementing a hazard mitigation plan for communities. These communities can then become more resilient and better prepared to face future disasters, ultimately saving lives and minimizing economic costs. As you know, this is an ongoing problem we heard about earlier. Beneath our feet in central Illinois, which is where I work, I'm located in Champaign, Illinois, is the Mahomet Aquifer. It is one of the most important water resources in Illinois. So the Water Survey developed the Illinois Groundwater Flow Modeling Framework, which covers the entire state of Illinois. The Mahomet Aquifer Groundwater Model was the genesis for the state model, which varies in resolution across the state depending on the intensity of the water withdrawals for supply. Daniel Abrams will present some of this work later today. Drought and flood condition scenarios are simulated with the model to explore supply, demand, vulnerability, and possible risk assessments at local or regional scales. Simulations can be as small as individual groundwater wells, which is informative for municipalities, industries, and irrigation for important water supply decision-making. The focus on the computational hydrology for decision support group is the nexus of integrated hydrologic modeling and human water use. So this effort promotes novel techniques to improve spatial characterization of groundwater levels and works with transportation managers to understand the impact of rising groundwater in flooding roadways. These projects leverage numerical and analytical models coupled with automated computing algorithms. In this scenario, do you see it moving? Oh, there it is. I started it moving there. In this scenario, watch how the runoff, the pink bars, increase dramatically on the roadway when the water table, which is the blue line, meets the land surface. The roadway was built below the natural water table when the water table was artificially low due to surrounding industrial pumping activities earlier in the century. This model simulates how fast the water table rises when maintenance pumps have been shut off. To the right, the integrated hydrologic modeling efforts utilize advanced knowledge of interactions between the atmosphere, surface, and groundwater to provide a deeper understanding of physical processes. In this example, it models the seasonal variation of soil moisture within the unsaturated zone, utilizing University of Illinois' high-performance computing resources. The Water Survey uses both ModFlow and ParFlow modeling software and is developing AI modeling capabilities in its current research areas. The Computational Hydrology Research Group also allows us to evaluate the present and future fate of and transport of solutes through the groundwater that can pose a threat to environmental and human health. We heard a little bit about these issues in groundwater earlier today as well. The current fate and transport studies include the accumulation of chloride from drinking from water de-icing chemicals, volatile organic compounds from industrial sources, and nitrate from agricultural applications across the state. By creating and applying ModFlow and modular transport 3D dimensional multi-species models, new research efforts in a proposal stage include the development of local scale framework for 3D PFAS groundwater modeling. The Water and Public Health Program provides resources and support for community water and wastewater operators, a decentralized on-site professionals and private well owners while investigating emerging groundwater issues locally and nationwide. The impact is accomplished through education, outreach, integrating information, individual support service, and research to advance the science and awareness of these disciplines. Feel free to explore this and search for this group online. They have lots of outreach activities every month. Oops. All right, the University of Illinois and the University of Birmingham in the United Kingdom have had a bridge program for international collaboration for the last 10 years. These are two active research projects. One is a global collaboration for climate action for enhancing water resilience through machine learning and a process-based modeling. This uses long-term data sets and advanced AI/ML capabilities to improve the simulation and prediction of watershed responses. This work will provide critical insights into the watershed sediment and nutrient dynamics supporting water resilience. A second project evaluates nature-based solutions for mitigating climate change impacts using integrated soil infrastructure for water plan monitoring and modeling. The work explores a plant's role and nature-based solutions to mitigate urban heat island effects, soil infrastructure quality, integrating lab testing, field data, and hydrologic and water quality monitoring. Overall, these examples highlight how the Illinois State Water Survey connects field observations, stakeholder needs, and advanced modeling to address water challenges from local management decisions to statewide resilience planning. We welcome collaboration in applied projects co-developed with communities and agencies to do more theoretical work in hydrologic processes, data science, AI/ML that advances water research. If any of these topics or research methodologies align with your interests, I invite you to reach out to explore how our groups can learn from one another and strengthen our global partnership advancing water science. Thank you very much and for this opportunity to present to this great group.
Thank you very much, Dr. Bauer. And now we are ready to listen to Dr. Diego Chaparro from Aquatic Microecology Lab with his presentation, Mexican Aquatic Systems Restoration and Their Biological Diversity. Thank you.
Can you hear me?
Yes.
Thank you. Thank you. I'm sorry for the technical difficulties. Look at presentation.
Yeah, but could you put it in full screen, please?
Okay, sorry.
Now it's okay. Thank you.
Vale. Hi, sorry for the technical difficulties. I am Diego Chaparro. I talking about Mexican aquatic system restoration and their biological diversity. The project I will presentation the work of Aquatic Microecology Lab. The work done in the laboratory is related to the topic Mexican aquatic system restoration and their biological diversity. The laboratory is made of professor research, the Dr. Pedro Ramirez Garcia is a boss. The student are students, postgraduate student, PhD student, master student, also bachelor student. It's very important collaboration and funding for collaboration are other university in Mexico and international university and a government agency. The funding is important for resource. The resource is the dependence, international dependence and national dependence. The projects in the laboratory focus around conservation, aquatic species, and restoration body of water. For example, effect of flooding constrict wetlands on phytoplankton behavior and water quality change in a mesotrophic body of water. The general objective is to determine the efficiency of fluorine macrophyte highland hazard purification system in a drinking water reservoir. This is a scope. The one scope is the purific efficiency of the fluorine macrophyte island was evaluated from physiochemical analysis and mass balance. The other scope is a general database of environmental condition, water chemistry, and the biological pigments to relate them to the presence of cyanobacteria in the reservoir from the installation of measuring sensor. And final scope is the identification and counting of cyanobacteria species by microscope and the determination of microsystem were carried out monthly in order to later relate the presence to the physiochemical factor. Because it's very important to study cyanobacteria in body of water, cyanobacteria produce toxins. Cyanotoxin is very dangerous for all the species, beer, amphibians, fish, reptiles, mammals include the humans. This is in this picture. This is the drinking water reservoir affected by increase in cyanobacteria. Dam Valle de Bravo Dam. In this picture, look in the bloom cyanobacteria. This picture is before installing the flooding macrophyte highland. This is an important research study because Valle de Bravo supplies water to approximately 6 million people in the metropolitan area of the Valley of Mexico, which include Mexico City and part of the state of Mexico. This is to evaluate the removal of nitrogen and phosphorus by Phragmites australis and Xenoplectus californicus on flooding microphyte highland. Because it's important removal the nutrient because it's a nutrients for the increased population of cyanobacteria. Currently, the increase in pollution of aquatic systems is sad already. Not only cyanobacteria, it's more contaminant. For example, it is not only human beings who are being affected by this problem. Many new pollutants emerging pollutants and affecting the biodiversity of aquatic systems. What are microplastics? In the laboratory are many projects focus analysis effect and microplastics in different species. Effect of microplastics of biofilm reservoirs on the intestinal bacterial infection rate, the Urodel amphibian Ambistoma mexicanum is a project in process. Other project in process is effect of climate change on the toxicity and the bioaccumulation of microplastic in early larvae Ambistoma mexicanum is in process. The two projects is a study of postgrado. The transfer of microplastics from the zooplankton amphibian Urodel food web Ambistoma mexicanum endemic to Lake Xochimilco in Mexico City is a project finished and publication. This project, determination on the transfer of microplastics from the predation, zooplankton Ambistoma mexicanum and amphibian endemic to Mexico. Is a really mentioned zooplankton is the main food in the first weeks of the development of Ambistoma. For Ambistoma. And zooplankton feed on phytoplankton, being the transfer vector of microplankton in the actual food webs. Look in the video, the body and cladocerant is adding adding the microplastics is a problem for the same to flooding in children for swimming. In this case, no is detected for ambystoma. This is an study Diana Manriquez for master research in biological science. This study is publication in journal Food Webs in 2023, and microplastics are transferred in trophic web between zooplankton on the amphibians, Axolotl and Mystoma mexicanum, effect on their feeding behavior. Other publication for this project is effect of acrylonitrile butadiene styrene secondary microplastic on the demography on the demography Moina macrocopa and Cladocera. In this project, observed the affect the Cladocera in survivor. Because study axolotl are genus ambystoma, because all species of the planet have the right to a hilly and definite environment. However, anthropogenic activities have destroyed the habitat of many species, for example, trash, deforestation, and westward discard, placing several species in danger of extinction, has is the case of many amphibians around the world due to many particular characteristics that they present. For example, it's permeable, skin, dependent aquatic system for their embryonic development, among others. In Mexico, endemic amphibians of the genus Ambystoma axolotl are suffering this consequence. In Mexico, they live 18 of 53 species of axolotls, of which 3 are threatened, 1 in danger, 11 subject to special protection, and 3 have no information. In the stand Mexican and 59. Environmental protection, Mexican native species of whale, flora, and fauna risks, categories, and specification for inclusion, exclusion, or change list species risks. On the other hand, in the USN, place 8 species in critical danger, 4 in danger, 3 in less concern, 2 with deficient data, and 1 species not evaluated. But what needs to be done, or what is being done to protect or conserve this endemic amphibian of Mexico? How the question is, can we restoration what we destroyed to conserve species? Of course, I told you, bioremediation is a magic. Using aquatic plants for the absorption for the nutrients and contaminants, using native plants, for example, Berula erecta, Polygonum mexicanum, and Hydrocotyl ranunculoides. With this plant, we have observed a decrease in nutrient, mainly phosphorus and nitrogen. Other plants in using for change water quality is a invasive plant, can also function as bioremediation. In a postgraduate project, we are analyzing biochemical dynamics of phosphorus and nitrogen in relationship with phytoremediation process using macrophyte iconoclasts and or water jacinto or lily, and its effect on the zooplankton community. In addition to absorbing, the water lily functional as a food for zooplankton, main food of axolotl. Remember, of zooplankton is first food in the first week eclosion of ambystoma at the axolotl. Other problem is the agrochemical. Currently, they are cultivation areas where they use agrochemical depollution the water. And so we can continue talking about many problems that affect axolotl, for example, agrochemical, warming global, or the combination of both. in laboratories to the joint effect of global warming and agrochemical pollution on the species Ambystoma mexicanum in Lake Xochimilco. The results in this project, the effect of agrochemical, specifically chlorpyrifos, affect embryonic development in axolot. In their forms, they not occur and cause poor development on the spine. All the work that has been done in the laboratory and the other parts of the world is always focused on Ambystoma mexicanum. However, other axolots suffer the same or worse effects, such as Ambystoma altamirani or mountain axolot, ajolote de montaña. Therefore, underlying tends to be undertaken in the following. A study, for example, a study of the distribution Ambystoma altamirani in relation to water quality and its functional in the food web. This a result is publication in the journal de Biología Tropical con a topic distribution of Ambystoma altamirani in relation to biotic and abiotic factor in this habitat. Factor X, biotic, abiotic, for example, oxygen, conductivity, pH, bacteria, zooplankton, etc. The second part in this project is studied is a PhD study, effect of climate change on two amphibian species of the genus Ambystoma from Lotic and lentic system temperature. The objective is to estimate the thermal preference of Ambystoma mexicanum and Ambystoma altamirani and different life states, to compare the locomotor performance of Ambystoma mexicanum and Ambystoma altamirani at different temperatures at different life states. We are also working with the highland axolot or ajolote del altiplano or Ambystoma belasi, relationship of physiochemical and biological parameters with the presence, absence of Ambystoma belasi, highland axolot, ajolote del altiplano, in Amelco Querétaro. The general objective is to relate the physiochemical and biological parameters to the presence, absence of Ambystoma belasi. One topic is very important is environmental education. It's very important to raise awareness among the population on this issue. But with the result we have obtained, we knock on many doors of political people because axolotl conserve to life and not be used a cultural or political flag. Concern about the extinction of several species of axolotl. For the result obtained in the investigation, we propose it to the Congress of the State of Mexico and City of Mexico, create the first law and of project to the axolotl of Mexico. And what do they believe? They listened to use, and it is being created, the Ajolote Axolot Law. It's currently in bill that is ready to be approved. A special law for the preservation of the axolot and its environment in the state of Mexico. In City Mexico is approved the law. This is the law, the axolot, the protection. To achieve this, we need many collaboration and financiation. Thank you very much. Muchísimas gracias. Gracias.
Thank you very much, Dr. Chaparro. Now it's time for us to go with Dr. Sarma. He's a professor from Aquatic Ecology Lab from FES Iztacala with a presentation called Plankton Bioindicators of Water Quality. Please, Dr. Sarma.
Thank you very much. I'm going to share my presentation. Can you see the presentation?
Yes, but could you put it in full screen?
Yeah. Okay. Do you see all the slides moving?
No.
Not it? Okay, I'll just tell. Now?
No.
You can go ahead with the presentation as it is.
Yeah, but is moving?
No.
Oh, but my slide says is moving. Just 1 minute, please. Can you see the?
We
Yeah?
have your slides. If you want, we can present them.
Okay. Either way, no problem.
Oh,
okay,
now they move. Now they move.
Now they move? Okay.
Yes.
Okay. Now also they move?
Yes.
Okay, excellent. So I make the full presentation mode. Maybe then is the problem here. It's not moving. It's moving now.
Go to the next, please.
Yeah?
No.
Okay, then I cancel it one. Okay, probably in this form they move. Okay, now can you see the movement of the slide?
Yes, now we can see.
Excellent. So I talk about one of the bio indicators. The previous brilliant speakers already have mentioned some aspects of this one. And the treatment of water is one aspect, and to see its quality is another aspect. So there are many bio indicator organisms. There are at least 1.5 million species of animals, and many of them have got bio indicator value. It's not easy to include a large number of them. Similarly, there are about 300,000 species of plants, and not all of them can be useful. So what I do is I reduce the plankton bio indicators to one group of zooplankton, that is on rotifera. And whatever I mentioned, most aspects of the zooplankton as indicators of water quality are also applicable for phytoplankton. And species that I deal with here, the zooplankton rotifera is also a representative zooplankton, and it can represent many aspects of other groups of zooplankton as well. And therefore the formula, the strategies applied for the rotifers are also applicable for other groups of zooplankton. Namely, here you see in any given water body, take 1 liter out, you don't have to filter anything and observe under a microscope. Most likely you will encounter 4 groups: ciliates, rotifers, cladocerans, and copepods. The cladocerans and copepods together are called crustaceans that are common in most freshwater bodies. So slides are moving, right?
Yes.
Okay, excellent. So what first, before I talk about the use of rotifers as indicators, so we need to know small information, very short information about their characteristics. They are pseudo-coelometa bilaterians, that is, there is a gap between the body wall and the alimentary canal, and this gap is not lined by mesoderm. That is why they are called pseudo-coelomates. The blastocele of the blastula development during the embryonic development is continued in the adults. They have anterior modified corona. It is useful to, this is the most important organ exposed to the environment for the first time. And then the cilia you see on the top, they have got capacity of chemoreception and mechanoreception, and they detect which particle to be utilized to be consumed, which particle to be rejected. Now, there are also other features. For example, they have a modified pharynx into jaws to cut the food particles into tiny bits before consumption. And one of the characteristics of rotifers is also constant number of cells. This called utili. When an organism has constant number of cells, a part is cut, it cannot be again regenerated, because before the animal is born, the number of cells to be present in an organism are already known. The number of cells that are present for each species is specific. Normally, a rotifer may have about 800 to 1000 cells throughout the body. Nematodes also have the same characteristic. However, each organ has a different number of cells. Whereas in rotifers, each organ of a particular rotifer species, the number is constant. The total number of cells are constant for rotifers and nematodes, but each organ is also specific in terms of the number of cells that are present in each of them. They feed in microalgae, they feed in bacteria, detritus, and so on. Therefore, they are food linked in the aquatic ecosystems because zooplankton are the food for the larval fish and crustaceans. There are two groups, Pararotatoria and Irrotatoria. The Pararotatoria marine species and Irrotatoria, there are two subclasses. Deloidium, you can see here. These are very important for people who study genetics because there are no males. There is no real meiosis. There is a modified meiosis recently discovered, and they can live in the frozen waters for a period of more than 24,000 years. This has been recently discovered, and they have another ability called when the water is dried, they have to survive in the dried water bodies. So they form cryptobiotic forms or anhydrobiotic system. In this, they lose about 90% of the water and become a resistant system, resistant bodies, and they can live in this condition for a very long period of time. They have another feature that is resistant to gamma radiation. Up to 1000 gray units, they can survive. To give you an example, 100 gray units can kill a human baby. So this is the ability that they have. Now, that is why they are resistant. They are not used nearly as indicators. But on the other hand, monogorons are about 15,000 species, representing about 100 genera. These are more important from the point of view of application, like food for the fishes in aquaculture or indicators of water quality. They do not have the capacity of cryptobiosis, but they produce cysts. These cysts can remain in the dried water bodies for a very long time, and up to 100 years we know from the sediments. What about the species diversity? Well, Mexico has about 400 species, around 403 as of now, and other countries bordering Mexico, the number is obviously less. United States has about 600 species. The number is not reliable because for the last 50 years, no information is added to the species listing. And Canada has about 400 species. And again, about last 2 decades, no research is done on that. Therefore, the diversity is not known. Now, what are the water quality criteria? Normally do not include plankton. Unfortunately, they include other groups of organisms. For example, they use, of course, physicochemical variables, and they also use some biochemical variables like BOD, COD, TOD, and so on. And Mexican Water Quality Index includes 19 parameters, but no plankton. US National Sanitation Foundation Index has 19 parameters, mostly physicochemical. They are also organic macroinvertebrates, but no bioindicators are used. European framework, water framework directive also has many physicochemical parameters, but no zooplankton included. Therefore, we are missing some part to use them as indicators of water quality. Now, the use of plankton, it has got more advantages compared to physicochemical parameters because an instrument cannot detect the presence of minute quantities of substances, but zooplankton can detect it. There are other examples of using rotifers, particularly as indicators of water quality. There are very high diversity. There are about 2,000 species, and then 2,100, and then the worldwide distribution. They are not restricted to any particular water body, and they are used in ecotoxicology, like Cladocera, and they are sensitive indicators of small changes in pH, salinity, temperature, and any other variable. And rotifers respond differently. In what form? That I will deal with now. And they also, the method that are used for bioindicators are non-destructive. I can still use the specimens that are deposited in the museum 100 years ago and compare how the climatic changes have affected, global changes affected. And most species that Dr. Nandini already mentioned, they're taxonomically well defined. You do not need molecular tools. Of course, they are there, they help a lot. Preserved samples, they are not really useful for molecular tools, but you can use them for ecotoxical, for bioindicator value. And the long-term use is useful. Sometimes the instruments cannot detect the concentration of the toxicant, but rotifers can detect. And there are three terms normally used in the literature: that environmental indicators, ecological indicators, and the biodiversity indicators, and so on. But there are many other terms as well, and they have overlapping meaning, but they all mean only one thing, that they are sensitive indicators of water quality. And other terms normally used in zooplankton: compliance indicators, diagnostic indicators, early warning indicators, or even bioconcentration, bioaccumulation, and biomagnification, depending on the sample. The sampling strategies are very simple. What you need is a plankton net of about 35 micrometer pore size and a very simple microscope to identify the species. A compound microscope is sufficient. You do not need electron microscope for identification of more than 90% of the species that we have in the world. So for any purpose you collected zooplankton, rotifers, for example, it can be for qualitative purpose, where you do not know how many liters of water you filter to concentrate the zooplankton, or quantitative, you filtered only 30 to 40 liters, or you collected both qualitatively and quantitatively. All the three methods can be used for identification value of. Here I give you a panoramic view. If you collect qualitatively, well, you do not know how many liters you filtered, no problem. There are items, there are different formulae, there are different uses. You can detect, first of all, alpha, beta, gamma diversity. Then you can also compare between two or more water bodies and species richness of a given water body, which water body is more diverse, and therefore it requires protection. And at the same time, you also have native species and endemic species, exotic species and alien species. So all this can be detected based on just qualitative sampling. There are also species ratios that indicate the water quality, and some species are very sensitive and disappear the moment it changes in the water quality, like a pH, for example. And there are also some species who indicate the geographic indicators of a particular region. Now, in terms of the qualitative sampling, if you have a known quantity of water filtered and concentrated the zooplankton, then you have total abundances, relative abundances, and there are trophic state indexes specific for the rotifer group. Now, then if you have collected qualitatively and quantitatively, of course, you have many more diversity indices which can be used, including multivariable variate analysis. And together with, if you have physicochemical variables, that will be ideal. So geographic distribution of species, for example, if you give me a sample that contained Horella thomsoni, I can tell you 100% this is a neotropic species. It cannot be found in other, at least as of now, it is not known in other continents, in other geographic regions. And rotifers also indicate the habitat. For example, Brachynos, Aneuropsis, Keratella, Notolka, these are some of the genera 100% planktonic. They are now found in the benthonic. On the other hand, there are some parasitic species, for Ascomorphella, for example, Provalis, these are all parasitic on phytoplankton, and there are also some species parasitic on animals, and they cannot live without the host. There are also species sessile, there are also species benthic, although some of them can be found in both cases. Now, species ratios, if you see, you need to identify the collection of the zooplankton of the rotifer up to species level in order to apply this quotient. And if there are more number of Lecane and few species, more species of Lecane and less species of Brachynos, that area is that zone, that water body can be classified as lateral periphytic. There are other limnatic habitat and semi-limnatic habitat as well. And what about the physicochemical parameters? Do rotifers respond? They do. Typical acidic waters, you find asphalta, elosa, 100%, it can live up to pH of 2.5 without any problem. They're not only living but also reproducing. And most species are alkaline. These represent Asplankana, Brachiones, Lecana, Lepidella polyarthra, and many other. And some of them are urea ionic, and they can live up to moderately alkaline, moderately acidic. For example, they're 6.5 to alkaline up to 11, 10.5 to 11 also. There are also some species which require very high oxygen. There are species that can survive in low oxygen as well. So these have been known from the field samples at the same time when physicochemical variables are collected. Then there are also species with typical temperature. For example, Lothalca labis, when the temperature is more than 15 degrees centigrade, not only population dies, there is no reproduction. A few individuals might live, but they will not reproduce anymore. On the other hand, Brachiones is a typical tropical species, pantropical. It can survive up to 35 to 40 degrees centigrade, but when the temperature falls below 10, they survive, but they do not reproduce, and in course of time they die. Without reproduction, that is not useful for a population. They also indicate
2
the
minutes,
salinity.
please, doctor.
What is not moving?
2 minutes more, please.
Yeah, I'm moving fast. I don't know why I got much less time, but anyway, then there are also indicators of salinity, and then we also have the trophic conditions in the water bodies. Why they Bravo is an example that we have used different ratios of the different species, Brachiones and Trichocerca, they clearly indicate. However, this is not useful for high altitude water bodies because they have some behavior typical to temperate water bodies. Therefore, they are not used, and some species are typical for sessile, they are associated with the plankton, they are associated with macrophytes, and this is very important. The rarity of common species, you do not take into account some of the most common species gradually decrease in their abundances and gradually disappear with the time. And they also indicate if you do not have the capacity to identify the species up to species level, no problem. If you know the density that is sufficient, if the total number of individuals are less than 500, that's oligotrophic, and more than 300 is hypertrophic. And we compared this information with oligotrophic condition in three water bodies in Mexico, and we have the different types of diversity as I mentioned, gamma, alpha, beta. Then we have also a host of species diversity indexes. Any one of them can be used. They also have got saprobic value, and based on that, Pantel and Buck information can be useful to decide water quality. And we also have compared this information with water quality variables in Mexico, and rotiferous also shows changes in the morphology in relation to salinity. And we also have exotic species which are not found in Europe. Later on they are found, and there are specific trophic state indexes you can use. We also have applied for Mexican water bodies. And in conclusion, due to their high sensitivity and species diversity, they are ideal to evaluate the water quality, and different types of indexes are available, and they are applied already, and some of them are not applicable, unfortunately, because of the high altitude water bodies in central Mexico. But we can resolve this one with the help of project from UI Mexico collaboration. I thank you all.
Thank you very much. And also, I like to highlight that the presenters are answering the questions via text. So if you have more questions, please write them and they will be answering via text. Thank you.
Great. Thank you very much. Great presentation. Thank you. Now we will continue with our last speakers. Last but not least, we're very excited about the presentation of Daniel Abrams. He is a principal research scientist, groundwater flow modeler, Illinois State Water Survey, Prairie Research Institute at the University of Illinois, Urbana-Champaign. Thank you, Dr. Abrams. Please start.
Yeah, thank you, everybody. Thanks to all the speakers. Thanks for the session today. I've learned a lot going through this. So thank you, everybody. Again, my name is Daniel Abrams. I work with Aaron Bauer, who presented earlier at the Illinois State Water Survey. And what I want to talk about is one of the regional challenges that we faced here in Illinois in the southwestern suburbs of Chicago. and the way that we were able to address this. So walking through then, for those of you familiar then with the Chicago region, on Lake Michigan, just to the southwest, there's a cluster of communities that use a lot of groundwater. And I'll talk about the specific types. For now, just think shallow and deep sandstone as the two. And often this area is known as the Joliet region because it is the largest community, the most wells, some of the most growth in recent years. And then at the start of today, Dr. Haverlock showed some cones of depression. You'll see those again here. Those are centered on Joliet, but it's not only Joliet that's driving the decline. We also have a number of communities in the region, and we have industries also utilizing the aquifer. From 2019 to 2022, the Water Survey worked closely with a lot of communities and industries. This was a very collaborative study to examine water supply in the region of both the shallow and the deep sandstone. So in this image, I want to explain the deep sandstone because it's different than a lot of the aquifers that we deal with in the state. A lot of the aquifers are just in this upper crust, this yellow, the unconsolidated material. That's where a lot of the water use is. Also in the upper bedrock, that's the shallow aquifer system. I'll talk briefly about that at the end, but what I really want to lean into here is the deep sandstone, which you see in blue here, and the red line shows where water levels currently are. Now, the uppermost is the St. Peter, the lower is the Ironton-Gellsville, and the water levels are different somewhat. The Ironton-Gellsville water levels are deeper, but what you're going to notice is they're very deep. For perspective, to get down to the lowermost sandstone that you're seeing here, that's about the height of Willis Tower. So substantially deep declines, and this has been reducing water from pressure. We've been doing that for a long time. In fact, this animation will show you just what that decline is. Now, we're going to start here. You see at the center, this is Chicago, as you can see where my mouse is. And you'll start to see a lot of growth happening in the 1940s. You'll see the formation of a second center of the cone. That's the Joliet cone. There's a cone up at Milwaukee. And then as this goes on, you'll actually see that circle around Chicago start to go away as growth happens because Lake Michigan, we talked about that a little bit earlier, how Lake Michigan is an important source of water, and you start to get communities switching, and there you can start to see the circle going away, but the suburbs have really started to deepen. The Joliet area really starts to deepen, and this continues on until 1980, when so many communities started to switch off of the deep sandstone because of the decline, because of diminishing water resources. And so this will then continue. You will get the westernmost suburbs switching, but the Joliet region persists. The southwest suburb, that Joliet cone of depression persists. We could march this into the future. Really, it's just going to continue to show growth. You're kind of getting the idea here. You're going to see this really start to grow in the 2000s. That's when a number of changes happened in the way wells were constructed, where they were constructed, and now you see that deep cone. This has now reached unsustainable conditions. Here you can see modern pumping in the area. This would be I'd say about 6 or 7 years ago, accurate as of that. And you can see where the users are. A lot of these larger ones are industry again. Roughly 60% of the current demands throughout the entire region would have to be removed to be sustainable. You can see that in this plot. The blue is what's sustainable. Everything pink, that is what's being pumped that's unsustainable. And unsustainable withdrawals lead to drawdown. That in and of itself isn't a problem until the water level falls into the sandstone. That leads to issues. The sandstone can cave. The wells have to be rehabilitated. Drillers reach a limit on how deep they can drill the wells. It becomes an infrastructure problem, really, before the aquifers even go dry. And you can see the region here again. I pointed it out already, but this is the region that many communities, as a result of the study, the modeling, we looked at current conditions, we looked at 2030 out to 2050, and many communities, all of these in red, made a decision to change their water resources to Lake Michigan. Now, did that resolve the problem? Actually not. You can see that risk still persists throughout the aquifer in the uppermost St. Peter and the lowermost Ironton-Gellsville. This continues to be something we keep an eye on. The new center of the cone has shifted up toward McHenry County, but also it persists around here with the industries, where water reuse certainly is still on the table and certainly will be important to preserve this resource. All those communities wasn't enough to completely preserve everything. Part of that is frankly because of the presence of the fault zone, which really complicates water resources. It's an unfortunate reality. Joliet leaving the sandstone was not enough. Several communities had to follow. And we're also dealing with the case that future growth in water demands is uncertain, magnified by when and where industrial demands may go in. So even though we have this resolved, this is still a huge question. And how, does it matter? This is how it matters. Think of these categories in three different ways. Moderate means you're going to have to rehab your well more than you're doing now. High risk means there is a chance that drillers are not going to be able to continue to rehab your well. Excessive risk, that almost moves from a chance to a certainty that this well will no longer provide the water you need. And if we get a 3 million gallon a day user for new demands, whatever that source is, if we weren't expecting it in that region, and we often don't know when or where, that can spike up demand from high to excessive. And this may seem like something unrealistic. It's not. This happened in Joliet in the 2000s, and it's something that anywhere we see risk, this has to be on people's mind. Okay, that is the major thing I wanted to talk about just briefly. Want to close here with other projects we're doing. Our modeling, we're moving our modeling into a Python environment. This allows us to streamline all of our data inputs into our groundwater flow models. It means we're moving toward living models so that our demands are updated, our water levels are updated, so that we can find issues like the Joliet issue ASAP from our model and not have to wait until we have a modeling project to encounter it. So the idea of a living model is something we're building. That model, we can build an inset model to zoom in locally and be able to look at those local conditions. So this is something else that we're working on, the ability to zoom in locally from that regional model. We're excited about this. Geology throughout the state. We have very detailed geologic studies. We love those. Great information. We also are working on just getting a coarse depiction, just using well log information. And this has been transformative in how we can look at regional models. Machine learning, high performance computing. The bad part of the model, it takes 24 hours to run. How can we get that quicker? Can we improve it with machine learning, high performance computing, get better uncertainty analyses? All of these parameters are parameters that go into one groundwater flow model to look at recharge conditions. we need to be able to test a lot of different scenarios. We're getting there. And then what is sustainable? How can we help communities look ahead? Many communities got caught almost running out of water and are scrambling to 2030, which is pretty close. How can we help communities understand what is sustainable with our modeling? That's one of the major things we're working toward. And then the Illinois River Basin Study, something I've been working on. This allows us to look at nitrate denitrification throughout the entire Illinois River Basin in the subsurface, in the aquifer, and try to understand delivery of nitrate to streams, that long-term legacy that can come from groundwater. Okay, that was just a brief overview. I'm happy to take any questions. And again, thank you everybody for putting on a wonderful session today.
Thank you, Dr. Abrams, for your excellent presentation. Probably you may answer some questions at the Q&A window. With this final presentation from Dr. Abrams, we're finalizing, we're ending this first symposium of water and the environment, this joint symposium between FES Iztacala UNAM and the Illinois University System. We thank you all of our all of the people that has joined us with their questions, and also we thank all the conference partners that have been with us today. We hope that from these presentations we may find common points of collaboration. We have many other partners in the water topics, we know that, and still we may find a common ground. There's a lot of things to do on water issues in Illinois, but also in Mexico City. So we hope we find this common ground to further collaborations together. Thank you all for joining us. And thank you, Dr. Elvira de Mejia, for the organization of this symposium. And I don't know if you would like to give us some final words, please.
Thank you very much, Dr. Francisco Turner, for closing the session. And just on behalf of I-MMAS, I thank all the speakers for their meaningful and engaging presentations. We have learned a lot in these hours of presentation. Thank you for the exchange of knowledge and experience on the highly relevant topic of water and the environment. I want to thank the National Autonomous University of Mexico, Facultad de Higher Studies, Faculty of Higher Studies Iztacala, the University of Illinois, Chicago, Urbana-Champaign, and Springfield. Thank you all for your generous collaboration, and I hope you can find a partner that can collaborate with each one of you and submit grants. We will have the call for proposal, seed funding in early March. So please show your video, speakers, so we can say thank you to you. If you want to open your videos, speakers. So we will thank you. Can we do that? Can we do that, Eric? Please.
Yes, I believe everyone is showing the video now.
Okay. Can you remove the slide so we can take a picture of everybody, please? Okay, if we have your video open. Thank you so much. It was a wonderful session. All the topics well covered extraordinarily, and we want to thank you. And I really hope that you identify a partner in your area of expertise, so you can apply for these funds that the rector of UNAM and the president of the University of Illinois System have for us for this this year. Okay, so it's a
Thank
great.
you so much.
Well, thank you. Thank you for your knowledge. Thank you for wonderful research and training
Thank
great
you.
professionals and students. So I appreciate very much your time, your patience, and all the wonderful things. We even learned that there may be a law, right? A law related to cleaning Xochimilco and many other places. So thank you all and have a great day. Our
Thank
gratitude
you.
to all of you. Thank you.
Bye-bye.
Bye.
Thank you. Thank you. Excellent.
And the attendees can obtain your certificate from the University of Illinois system if you click to the link that is in the chat, please. So you will get your certificate of attendance. Thank you.
Muchas gracias.
Muchas gracias a todos. Gracias, amigos.
Gracias.
Bye.
Hasta
Thank you
luego.
very much.
Thank you.